Hey everybody, we got a little bit lost yesterday. We got a little bit off track. We're stuck here in this cave right now. We need to get back to stats. So need to know, is everyone ready for stats? It's a little echoey in this cave. Is everyone ready for stats? Oh no, no one's ready. I'll be stuck in this cave forever. One person's ready. A few people are ready. You know what? I'm ready for some stats. Let's do this. Let's do this. We're already in the notes. I was trying to, for some reason, we decided to do that today. Oh, wait. Turn off the echo. We decided to do that today just to have a little bit of fun, start class, do a little bit of craziness, who knows. But, we have our fun at the start of class. We have our 5 to 10 minute fun, sometimes 15 minutes. And I'm glad everyone can hear me. When I went to stream, every once in a while, something weird happens. And this morning it was like, live streaming is not available. Some randomness, you got it. Random button doesn't work right now. Also, the buttons are acting a little bit weird today. Is it working? Yeah, the buttons are acting a little bit weird. I might have to actually click them on the screen. So, and I will try to fix the orientation on these. Sorry, it was this thing yesterday. I should have really looked into it. But for some reason, I set this all up at the start of the semester. I got all my screens. I might be able to fix it on the fly. Let's try to, what I'm going to do? It's bugging me. Let's fix it a little bit here. So I'm going to have to, you're going to see behind the scenes. You ready? Everyone's going to see a little behind the scenes. Let's see if Streamlabs is working. Let's see if Streamlabs is doing its thing. And if it's not, I'll fix it. See, look, there's the edge of that slide right there. I'll make sure Streamlabs is working. There we go. And then this, I got this whole thing set up. Okay, let me make sure Streamlabs is on. Let me do that, because that'll be worse if Streamlabs is not on. No one's seeing what's there? Okay, so do I actually have to click this each morning? Because usually I go in and click this, and then I was having a tiny bit of trouble this morning. Okay, I'm doing what I usually do. Let me go to CloudBot. CloudBot says it's on now. So CloudBot is reporting that it is working. Let's see. We definitely want to make sure everyone's getting their points. So it might just take a moment now. I went in because it doesn't look like it's reporting them. So we'll check in 5 minutes or so to see if CloudBot is working. Thanks for everyone for checking your points. Just takes me a moment to ensure that CloudBot is on, but apparently I need to turn on CloudBot, which I thought it should just auto-load. Let's decrease the size on this. I wish I could grab the corner of that. There we go. See, that's a little off the edge right there. You can see it. There we go. Look at that. Now it's off the top. There we go. Look at that. Way better. Let's do it. There we go. How's that look? Is that nice and framed up, everybody? Is that really good? Just takes a moment right here, but just have to remember all these little tiny things. So the points should be working again here in a moment. Sorry that looks good. I like it. So I set it up. I had all these numbers down, and then I don't know if they updated Excel or what they did. I mean, not Excel, PowerPoint. But for some reason, the framing changed. And I'm like, come on. I framed this up nice and perfect. I want it to look like this at all times. And so then, like the first few lectures worked perfectly. And then I don't know why they would update it. I don't know. Things happen. Could just be the slides have different dimensions. I should go look at the other slides, make sure they're all standardized. Okay, so Streamlabs should start working soon because I did the thing I usually do to get it to work. And we'll keep our fingers crossed. If for some reason Streamlabs doesn't work, I will give everyone 300 points. So someone's probably like, please, Streamlabs don't work. What impression am I doing? But they're probably like, please, I'd love that. But I think it'll start working. It usually takes a few moments after I do all this. So we'll check back on Streamlabs in about 5 minutes. Unless it starts just telling us points right here. Which it should. I'm running OBS Streamlabs, and it should be connected in. So Streamlabs, where are you at? Streamlabs, you're supposed to be helping out. You're supposed to tell me you're my TA, Streamlabs. So it should start working soon. So sorry if it's not working right away. I love that you guys love the points. I'm so glad. And I need to figure out why sometimes. I think it's because I don't go and do that thing. I kind of confirmed it. So let me just look again. Streamlabs should be on. How's everyone doing this morning? Monday, everyone was tired, which kind of makes sense. It's Monday. I mean, everyone's tired on Monday. I'm tired on Monday. I was tired yesterday. Drove to Kingsport. Oh, Streamlabs, you're back. We missed you, Streamlabs. Only Sarah gets her points. No one else. No one else. No one else Streamlabs for your points. No one else. Still tired? No one asked Streamlabs your points. Nope, can't. No, don't. Streamlabs worked so hard. More awake than Monday. You guys know we like to have our fun. Great job on all these points right here. Some of you have already reached the 1,000 threshold right here, and it looks like I do have to manually go in. And I don't know why it takes a while. I don't know why Streamlabs takes a little bit to boot up, but I've kind of noticed that over time, that Streamlabs, after I turn it on, it takes a little bit to actually get started. Okay. Eating avocado toast? That sounds excellent. I do like avocado. I do like toast. Avocado toast sounds great. So that's good right there. Everyone's getting their points. Okay. I think we are good to go. And I want to say this. You know what I'm going to actually do? I'm going to tell you. So do we still need to email you about the points we earned? Yes. If you earn them during class, you need to email me and try to do it when you get them. I just read my reviews this morning. I was like, should I mention that? They just released the reviews of like last semester on TN Voice. And I always read all the good and the bad. And luckily there's more good. There's some bad though. Of course there's always bad. There's always one person out of all my classes, out of nearly 500 students, to the question of the instructor replies in a timely fashion to your emails and to your questions. One person put strongly disagree. And I was like, no way. And so obviously I had a very unhappy student. But that's something I really pride myself on, and it's all right that they put that. They can put that. I'm not hurt by it, I swear. But if you guys know, I will try to reply. And let me look at the chat. I'm bringing up something as we talk about this. Thank you very much, Neeland. But I feel like that student maybe didn't quite understand, kind of that I will respond as quickly as I possibly can to every single question, every single email. It's my goal. And I don't have the chat up as we're speaking right now. I'm looking at something and I am confirming, yes, you guys broke a record, and that's what I'm going to tell you guys about in 1 second here. I'm looking at the numbers because I don't want to quote you fake numbers. But if I pride myself on one thing, it's my communication with my students. And you guys have been communicating with me, and that's awesome. And I try to communicate with you. And we're going to talk about another thing. Yes, you guys did it. You broke the record. You broke the record. I just confirmed it. Okay, so let's mention that record you guys just broke. So I got to say amazing job right here. What record did you break? You got... You guys are cracking me up. Who's going to hate? Thank you very much. So I will reply to your emails within, hopefully. Now, someone will be like, well, Monday you didn't. I was driving to Kingsport on Monday to a doctor's appointment. And then I had to go back and do work, and I've been catching up and everything. So I will reply to your emails. Just email me anytime you have a question. Please tell me what you're thinking. I can't reiterate that enough. But you guys have been stepping up your game. You guys have been working really hard, and I'm expecting some super high grades. Don't worry. If you make a 70 on the test, let's say you make a 70 on the test, and you're like, oh my gosh, I studied, I worked so hard, I made a 70, but you've been doing all the work in the background. What did you actually make on the test? If you make a 70, which I know there's a lot of good students out there that might make a 70, and they'll be like, dang it. Oh no, Claire, I'm so sorry. What did this person maybe make if they made a 70? Let's say they've been doing all the work. 85, you got it. I can't state this enough. And this is why I'm really excited. I don't want you guys to get discouraged. Because last semester, my in-class students did an amazing job and had some of the highest grades I've ever seen. I think I gave like 35 or 40% A's. Yep, you got it, Keaton. And so I'm just waiting for them to complain about that and be like, Brian, your grades are too high. Your mini-term grades are too high. They said one time. I want us to go back to those days where they complain and say, your grades are too high. And I say, well, my students are too smart. That's the problem. It's not a problem. They work too hard. And so here's the thing. And what I saw last night is that last semester, the in-class students got an 81 average. And these are the in-class students, which are usually easier to get to do work. Because if I'm doing work in class, someone usually... I've seen it. Someone will get up and leave. I didn't jinx you guys, I promise. So I've had people rarely to never get up and leave. Usually someone will pull open their computer, get their work done, and they got an 81 average on Chapter 5, Part 2. They had an 81 average. And you guys and gals and everybody got an 84 average. And I'm guessing it's statistically significant. That's a 3-point difference from a pool of 115 students in a pool of, it's a 2-sample t-test with 115 students from sample 1 and 70 students from sample 2. And that's an 84 average. And that's only with like 2 or 3 people missing the assignment. So congratulations. We need the crab rave. We can't do the crab rave on the screen, so we gotta do it over here. Let's do crab. Oh, I can't click my buttons. Buttons. Where are you at, buttons? If I load up Stream Deck, will it load? I need my buttons. Everything's broken this morning. You're gonna see Stream Deck probably appear right here or somewhere. Stream Deck? Stream Deck? Oh, you can't see it. Oh, there's Stream Deck. Now will Stream Deck work? It still won't work. Okay, I have to click the buttons. Okay, which button? No, so here we're gonna do a little celebration. We have to. So here's desktop. I have to manually click these buttons. Now you're seeing what happens when Brian has to manually click it. Guess what? We get it. There it is right there. We earned it. We earned it. We need the crab rave for this. We earned it. So we definitely earned it. Cool. This is my test, like when everything's broken. What? Why is it working now? Why? You can tell. I'll let you guys see this. Okay, now my buttons for my lights. Can you tell what every button is for? We don't use the rainbow as much anymore, but that's the rainbow. This is the crab rave. There's the extra credit. I can turn off my camera. I don't think it works on this screen. Yeah, it doesn't work on this screen. There's the daily event, Mega Man. So you can see, it'll tell me it's playing right now. So there's your little kind of like behind the scenes. There's our intro screen. There's the UT. Here's all the different things here. Can we see the rainbow? Yeah, I'll show you guys a rainbow. Here's a rainbow. So you go, just use your, can do it with it. There we go, the rainbow. So there's the rainbow right there. People came up with these ideas. Keep coming up with ideas, and we'll keep doing it. We've had some fun. Uh-oh, it sounds like it's not for that. And Rick and Morty. Yeah, I love the Rick and Morty button. That's my intro button right there for the Rick and Morty right there. The intro screen right there. So that plays our intro. So when I start class, I click, I click this button right here to get to the main watching the screen, and then I click this. So it's a lot of fun. It's a lot of it's kind of cool. And I've got Jason working on some new stuff right now, and you're looking at a screen capture of the PowerPoint. So you're hearing a little bit behind the scenes. Someone's take this idea. Now people can always take this idea. Other people's professors can use it. I love Crab Rave too. Everyone loves Crab Rave. You got to get hype when Crab Rave is playing. What you didn't do, I did at the start, Camden. You missed it. I didn't do all the voices.
There's still more voices to come. Don't worry, we've got other tricks to do.
That's a scary voice. Okay, so we've had our 10 minutes of fun. Are you guys ready to get serious here? I gotta hear how that sounds. Okay. Just so you can see that, this is our last thing. That thing right there is my device. I think I showed you guys this once before, but it's this device here. Oh, volume's a little low. I'll put that to put it to there. So I can control it. I can mute myself. So, and it also mixes the audio. So it's more than just a glorified push up, up and down the knobs. Okay. That's how I sound so clear. And if I go away from the mic, I'm still pretty loud because it raises and lowers my volume. And if I talk too loud, if you're wearing headphones, you won't hear me too loud because it's got a compressor in it. So I can't shout into the microphone and hurt your ears. It's helping out. Here we go. Get ready for Stats 201. It's time. So let's do this. Chapter 6 and 7 are on scatterplots, associations, and correlations. My neighbors will hate me. Scatterplots, associations, and correlations. If I knew no one was here, I would do it. But my neighbors would hate me, and then they'd start complaining, and I might not be able to stream from my apartment. I do wonder about it, too, because I would like to do it as loud as I possibly could and then see how it sounds just to check it. This is the last thing I'll say on that. It takes whatever audio is over the threshold and lowers it by a 4-to-1 ratio. And then it also has a peak, so I can't go beyond a certain amount. Can we talk about the exams and the logistics? Yeah, Camden, let's do that. Camden, so we're not starting a lecture right now because that's a super important thing because it starts tomorrow. So let me put the slide. Oh, it's over here. Good. Camden brings up a really great point. Let me show this. Let me hop over to the screen. I need to talk about this. Camden, I'm not giving away big extra credit today, but Camden, you get 50 points for saying that because you really helped me out there. We really need to talk about that real quick. So are we doing homework and quiz? Yeah, we definitely do that. Thank you, Sarah. Thank you for pointing that out right there. So you should see, you should see that there is a whatchamacallit? Under the quizzes, my camera did get moved. Under the quizzes in the class, there'll be a new quiz. So there's a new quiz. And has anyone seen it yet? I can't look at grades right now, really, because we're broadcasting. But has anyone seen the new quiz? Now, this new quiz has 5 questions. It doesn't count for points, but you'll log in to just check it out. I encourage you to do this after class. There won't really be, I don't think there's a single, if there are p-value stuff, I'll have to look. It'd be only like 2 to 3 points of the test. So don't go in depth on it. Don't be like, I need to understand p-values thoroughly. That's going to be more of a, like, the amount of p-value stuff on it is 2 to 3 points tops, I'd say, Claire. And if it's not, I'll probably throw points on the test because that's not my goal. It's not going to be a p-value thing. Did I miss it? It's the practice test 1. Yep. You could take it right now while I'm talking to you. So I'd maybe even suggest that. Go check out practice test 1. Oh, you can't because it's lockdown browser. So it's gonna kick you out of this if you do that. Don't take it right now. So it's meant to mimic exactly. Practice exam is to get used to lockdown browser to see what's going on. And so people wanted it yesterday, and so this is a big thing. Does everyone else see it? Does everyone else see it? It should be under quizzes. Can we get some confirmations that practice 1 exam is on there? And I might have to send out some screenshots. We should go to quizzes. I'm always afraid when I'm inside. I don't want to go to too many things. So it should be there. Go to quizzes. Make sure you're on quizzes. It's not, you can see it good. And so after class, check that out. Maybe there's a question with a hint on it, trying to pull your attention to some stuff. But you guys wanted this yesterday. Oh, the real exam's not there yet. So yeah, the real exam shouldn't, and don't, if you see other exams, don't take them. You should, maybe I messed up, but you should be taking practice exam 1. Check that later today. It'll take you, it's not worth a grade. It's just practice exam. There's only 5 questions. Hopefully you'll get 100 on it. Unless I made a mistake on it. There's 3 exams in the class, and I might put a practice exam before each test. But there's only 1 practice exam right now because I made it last night. And thank you for those who suggested it. I'm always going to kind of do what your suggestions are. It's very similar to the test format. That's what I do suggest using the videos I've made. Like, I've got the review videos you can find on stat1.utk.edu. You can find on the YouTube page. You can take the practice exam with notes. Yeah, don't worry. I'm not going to be reviewing those videos. So I'm not going to go in and be like, you cheated on the practice exam. No, it's just, don't worry. It's just to get used to the respondus and to see kind of what the exam format will look like. So people asked for it. I made it last night. Thank you very much for when you guys want something and everyone's putting the up arrows on it, then that's a big thing. Like when you guys are like, hey, can you do this? Can you make this? Exactly. Practice test 1 and practice test not a real test. Exactly. The real test is with no notes. It's very correct. On the real test, you can have scratch paper. You're welcome, Samantha. Thank you. Like, you guys just asked. Just be like, can you do this, Brian? Can you do that? That's a great thing right there. I think there's like 45. There's between 40 and 50 on most exams, I'd say. Between 40 to 50, somewhere in that range. Do we need to use the TI? You don't need to use the TI. You can't use jump on the test. So you can't use jump on the test. And so I'll need to make sure I mark that this is like talking about the test. And the test will be open Thursday to Friday. Beast mode. Oh, man, I love beast mode. I got to do a beast mode thing. Gives the people what they need. Thank you, Kyle. And we need to print anything for exams. Some of them will have formula sheets. You can print the formula sheets, or you can write them down. You just have to show it. You have to like show your formula sheet. I knew when I was turning on the camera, sometimes I just give it a little, I need to tighten it down because I pushed it a little bit when I turned it on. That moved the camera. So move myself a little bit over on the screen because I'm a little bit, you don't see as much as my microphone today. Oh wait, I could do this. Okay, I could do. And that could move the microphone a little more towards me. Oh wow, solutions. Who would have thought you could move over with a camera? Is the formula sheet already posted? It's on the practice test. It's very simple. I think the only stuff on the formula sheets is like, let me bring up a WordPad right here. So think the only thing on the formula sheet, it's so very simple. I think it's y hat equals b0 plus b1, and I'll make sure it's posted. And that's on the formula sheet, and residual equals actual minus predicted. I think those are the only two things on it. Yep. Remind me, Alyssa. Send me a reminder about that. The best way to always remind me of things is to send me an email and say, "Hey, Brian," in the email, and Alyssa, you're getting 50 points. What is this? This is Wacky Wednesdays. It's Remind Brian Wednesday. So in your email, you have to say you got the points, remember? And let's do a huge reminder right now. So our last little bit right here. But I want you to say to send a reminder of where those things are. Brian's very ADD. So you got to help Brian out. Those are Brian's initials. So make sure Wacky Wednesdays. I want to do Wacky Wednesdays. Please use the following. Can I increase everything? What happens if I hit increase? It doesn't. I thought it might actually increase those. Well, and so many of you are doing this. Thank you so much. And you will get a reminder at the bottom if you don't do it. But this really helps me a whole bunch to reply to everybody. Because sometimes I get emails that say like no title, and so it can be very, very confusing. Or a lot of emails will start out, "Hey Brian, I'm in such and such class." Usually I don't gripe too much if there's a small difference, but you got it right there. Thank you, Neelan. You know how to do it right there. It really helps. And literally that presentation I gave yesterday, one of my former students was in there, and he said, "I still use this to stay organized." So it's very, and the reason I have the initials here, people always wonder, why is it the initials? There was a problem when I first started doing this that emails would overlap. And so the initials kind of helps me. For some reason, Gmail was collecting them. I don't know if it still does that, but I fixed it by having people put their initials, because it used to just be stuff like that. But then Gmail had a problem with it, and it was like the emails started merging. And I was like, I don't want that. They're different things. So the initials was a added on thing. So people always wonder, why is that there? Because why not just Stat1 Mini title here? Because I know your name. It's in the email. So that's got it. And make sure those are your initials right there, not mine. So many people use my initials. It's like a lot. Okay, that's got it. Awesome. Thank you for posting the links. My gosh, you guys are awesome. Keaton and Gracie, you guys get 50 points. Keaton and Gracie going above and beyond, helping your fellow students. Keaton and Gracie, thank you so much. You guys did it. I didn't even ask you to, but you guys helped out your fellow students. You guys are awesome right there. We got the Stats1 webpage. Keaton posted it in the chat, and Gracie posted the exams page. Now make sure to go to like exams 1 or exams 2, and you'll see all the information on there. And I think the practice test I posted is a good example of how it'll look like. So you guys are awesome. Stats Nation helping out. We need some Stats Nation graphics. Get ready for them this weekend. Also, last but not least, I'm just like guarding ourselves here. Solar opposites, we gotta check that out. Make sure to remember that if you do poorly on the exams, like let's say this class is really tough right now for you. Let's say you're like, man, this material today, that normal curve stuff, really tough. And on the test, you make a very low grade, and I would consider this very low. You make a 40. This might be one person. I might be speaking to you. You might remember this. I want you to tell me, I think it's like 40 to 50, Alyssa, 40 to 50. I want you to tell me if you've been doing all the work. What do you all of a sudden have? This is just our big reminder, the big reminder of why every night we're doing all of our work. Why every night we're doing all of our work, which is that this is the best way I can keep you on track, is be like, you got to do the quizzes. Yeah, 70. Now, I'm not saying people want to make a 70. I'm not saying, woohoo, 70. It's, yeah, 70. You got it. We made it 70. So it's just happiness all day long, 70. No, better than a 40. Gracie. Gracie gets it. Gracie gets it. Whole lot better than a 40. And also a 70 keeps you in the running for stuff like B's. So it's going to damage your ability. I think there is the no credit option. Obviously take that if you want, but I think C's get degrees. I even would say that C's get degrees. D's get diplomas, depending on what the requirements are. We love B's, and A's are astounding. So A's are amazing. A's are amazing. That's what we say. Yeah, and I don't know how everything applies. Sorry, thank you very much, Needy. So some C's get degrees. Exactly. Okay, so that was our 10-minute talk on getting ready for the test. And remember, mini term is a sprint. I hate to say that. Every day you need to be doing something. And on the weekends, there'll always be assignments. I didn't mean to catch anyone off guard this weekend. I know we were all, showing our mother's appreciation, remembering our mothers or showing our mother's appreciation. Don't worry, my mom's still around, but not everyone's is. Probably, I don't know. Normal grading scales for summer. Yep. Are both the homeworks and the quizzes? No, just the quizzes. Just the quizzes. Just the quizzes. So the homeworks are their own thing, and the homeworks give you access to the quizzes. So it's important to do the homework. It's still a grade in the class, but if you do poorly on the quiz, then you have to do the homework to get a high enough grade on the homework to take the remainders. Does that make sense? And I think everyone's right. I think people are saying, does this make sense to everybody? Are we all on track? Are we reviewing tomorrow? We will be reviewing. You got it. You will not have to calculate variance or standard deviation by hand. More important to understand that standard and variance are measures of spread. About the only time we talk about variance is that standard deviation is S and variance is this. That's sample standard deviation and sample variance. That's population standard deviation. That's population variance. You really will never really hear me probably say the word variance again after class today. And the only test question we could really ask on variance is like standard deviation squared is variance. It's about as in depth as we go on variance, which just means they're kind of redundant measures. So, yes, note-taking quizzes are in the grade, but they're not in the quiz averages. The quiz average is only the MyPearson quizzes. Does that make sense to everybody? The quiz averages are only the MyPearson quiz averages. Do any of the note-taking quizzes get dropped? Yep, 2 of them will get dropped. 2 of them will get dropped. 2 of them will get dropped. If you missed the one last night, don't worry, not the end of the world. Just make sure not to miss them, and I would suggest making sure you have those notes. Now, I did something really special at the end of class yesterday for those, and I know everyone cannot stay, but if you are watching a video, and I do say something like I allowed people to take a screenshot of it, so we had like 15, 20 people watching at the end of class. It was like in the last final hour, and I drew out the whole curve, and then I said, if you are still here, you can take a screenshot and submit that. So I might do secret things like that for note-taking quiz. I can't. Everyone's going to want that every time, but maybe. Who knows? But I appreciate your guys' hard work, and I know there's a lot of work. I know mini-term is a sprint. Don't worry. I took it when I was at UT, and I was like, holy mackerel, 3 weeks have gone by, and I just took a class. So, Brian's breathing deep again. He's getting ready. He's getting all the knowledge in his head, getting the oxygen and ready for knowledge. Oh, and Jared, you can come back and watch these. So if you do watch it and it appears in the review, Jared, you can use it. And it is, thank you, Elizabeth. So if you do see it in a review, when you come back and watch it later, you can still use it. It's a test, more calculation questions. I think the practice test will give you a very good example of what it'll be like. It'll be a little bit like MyPearson, and it'll be a little bit, there might be even a question that it might be on the test, like the practice test. Thank you, Sarah. Thank you guys. You guys are awesome. You guys keep me really positive. Well, it's time to get more out of this class. It's time we understand what's going on with the world today. We understand about the test, and it is time to learn about correlation. Hair's just going to fall on my face. And so we have scatterplots, associations, and correlations. You know what? I've never broken down all the words right here on this slide. Let's talk about what every one of these words means. Every one of these words right here means scatterplot. One of the reviews I read said he just reads the slides. He said it again, and I just read the slide. Well, scatterplot is a bivariate display of quantitative data. Take that, review. I'm telling what it means. A scatterplot is a bivariate display of quantitative data. A scatterplot is a bivariate, 2 variables display, where both those variables, variable number 1 and variable number 2, are both quantitative. To repeat one more time, a scatterplot is a bivariate display of quantitative variables. What is an association? Now, this is another pet peeve of Brian. We talk about Brian's little pet peeves, and association versus correlation is one of my pet peeves. So, association, nice job, Devin, right there. Association, you can say things like this. You can say that, let's say attending class, like whether or not you attend class during mini-term in your grade, have an association. You can also say the more you attend class, the higher your grade is a correlation. Now, every single association is a correlation, but not every single correlation is an association. When would correlations be an association? So not every single correlation is an association. Oh, no, did I just do it wrong? Oh, no, I didn't say all that. Not every single association is a correlation. Not every single association is a correlation. Pretty much like that, you're getting it, Sarah. And when is an association a correlation? When is an association a correlation? I'll make this a lot more clear because I misspoke and I think I heard knowledge. When is an association a correlation? Think back to what we were talking about right here. Not every association is a correlation, but every correlation is a association. Yes, Camden, great note in the chat. Camden has said it perfectly. Camden, 50 points. You put it perfectly, and everyone can see in the chat. Amazing work, Camden, right there. So going to class in high school and grades would be an association. You have to be. It almost can be a correlation if you say how often you go to class and your grades, like how many times you go to class. Does anyone notice for 50 points? It's Wacky Wednesday. I made the points 50 right now. I'm going to try to do it less. Point values might change. You can only get up to 50 points today. I might change the points around. Can a correlation be negative? Yeah, you're kind of... Ben's got some knowledge right there. Ben, nice knowledge right there. You're kind of right. Ben's got some good knowledge. But when are things correlation? Ice cream and drowning victims. You can do that, which would be a correlation is not causation. Like how much ice cream is sold and how many people drowned. Oh, you can only get up to 50. You got it, though. Association is a relationship between two variables. Yeah, Sarah's on track. Sarah gets 50 points. So let's explain what Sarah's kind of pointing out. Sarah says that an association is a relationship between two variables, like your grades and whether or not you did the online assignments. Now that's an association, but I'm going to change it slightly. Listen to example 1. Your grades and whether or not you do the online assignments is an association. Your grades and your grade in the class and your grade on the online assignments is a correlation. Your grade in the class and your grade on the online assignments is a correlation. Maybe, Claire, I think that one works too. Close. Sarah's pretty much right. And by linear, it would have to go on a scatterplot. So I'm gonna give it away right here. You ready? So what does this slide say? Sure. Oh, here it is. It is on here. What is it? First person gets 50 points. It's Wacky Wednesdays. What is the idea between correlations and scatterplots? Both of these things apply to correlations and scatterplots. First person, 50 points. Who's got it? Correlations and scatterplots. When I say these things, you need to have a note on this. Correlations and scatterplots both apply to what? Too quantitative. You got it, Camden. I think we're gonna give it to Sam right there. Samantha, sorry. If you go by Samantha, just be like, it's Samantha Bryan. I'll not say Sam again. So I get people's names right. Samantha got it right there. 50 points. Nice job. This is the note you should have. Correlations and scatterplots are bivariate quantitative. Associations are just this. Associations are just what? I think it was Sarah was pointing it out earlier. Associations are just between two variables. But correlations and scatterplots are between two quantitative. Does this make sense? So when you say something's associated, you can say that X and Y are associated, but X and Y only have a correlation when the two things are quantitative. This will be a very important condition called QQ straight enough, no outliers, plot doesn't thicken. We'll be going to that here in a little bit. So this is a very important key understanding we need to have. Mosaic plots, which were mentioned earlier, are between two types of what variables, which are not scatter plots. A mosaic plot, which I'll draw on here right now, you're welcome. Yep. And do you prefer Sam or Samantha? Because I've said it like 3 times during the thing. I just don't want to... Because for some reason, my mind abbreviates. And so you guys are got Sam, awesome. You guys know it. So it's two categorical variables right here. But that's a mosaic plot between two. The screen suddenly stopped and I got really afraid. So this right here is mosaic plot. And a scatter plot, Sarah was telling us some great stuff. You can put a line through a scatter plot and it looks like this. So a scatter plot is a bivariate relationship. Space pen is back. We might do another pen today. A scatter plot is a bivariate relationship between two quantitative variables where both x and y are quantitative variables. And down here, they're both categorical. So we have two quantitative variables making a scatter plot and two categorical variables. Now you can do things making a mosaic plot. This is another bivariate display of data right here. This is side-by-side box plots. This is not a singular box plot, but my y-axis right here must be what? Because these are box plots. My y-axis, side-by-side box plots, the y-axis would be what? Go side-by-side box plots. So a little bit of review right here. Quantitative, you got it. Quantitative, and then the bottom is categorical. So it's like, think about it, it's like group A, group B. So we got a box plot for one group and a box plot for another group. And box plots are quantitative, so you have like multiple box plots. Doesn't have to be positive, Ben. You'll hear about that soon. You got it. Great question right there. Correlations can be between -1 and 1. And so we'll see in this chapter, the main goal of this chapter is to understand. Oh, because the pens? When I do the pens, does it do that? Oh, no. Don't change it. You gotta be kidding me. Don't. What have we done? What have we done? It hasn't been doing that every time, has it? 2 seconds, everybody. Brian broke the world. You know what it is? I have to fix this real quick. What it is usually I have the screen out, and that's why the orientation has been off, I think. So we got to fix this right here. So that's why the screen was all weird, is because usually, sorry, technical difficulties today. Usually I have the pens out. That's what it is. So, oops, and we need to pull this. Okay, wait. Nope. Okay, now that part of the screen's a little bit off. Okay, I think we'll be all right. Fingers crossed. So it's that I had the pens out. That little change right there was the only thing. I have the pens out usually, and that changed the orientation. Brian broke the world. Okay, let's take a look here. Okay, here's 4 terms you should know instantaneously. The 4 terms are strength, direction, form, and unusual features. Can you go over scatterplots that appear to be curved like a parabola? You bet. Yeah, I'll go over that at the end here, Sarah, because we don't do that in this class. But Sarah, at the end of this lecture, I want you to be like, tell us a little bit more about curved scatterplots, and I'll explain some stuff to you because you might be using that in another class, and I want you to have that info. So Sarah actually mentions it. Sarah, you get 50 points for asking that. You might already have it, but you're at 50. Sarah, and someone has to point out which of these relates to Sarah's question. Which of these relates to Sarah's question? Which of these topics right here relates to Sarah's question? So someone's going to get 50 points off of Sarah's question. Not direction. Not strength. Form, Gracie. I think Gracie's already got the points, so Nicole gets the points. Gracie, you've got the points. Great job, Gracie. And Nicole was second. I got to start remembering who's got it. Remember, 50 points right here. So we'll go to the one Gracie mentioned. I'm not Gracie. The one I think was Sarah mentioned. If you notice here, we have form. And here's the 2 types of form. You ready? Within form, you should have this note. You should, yeah, well, I'll tell you about it, Sarah. It's a great question. So here we are. Sarah mentions we have either 2 types of form right here. We have either linear or, so we've got linear, or what's the other type of form? So either things are linear or what? For 50 points, who's got it? Either things are linear or what? Either things are linear or what? Non-linear. Gracie, you're just doing an amazing job. So Zulon, you got it right there. Gracie, keep it up. Keep answering. People can take the answer when someone says it. So Gracie, amazing work. And Zulon got in there too with the points. So we've got some non-linear right here. If you notice, these are a little bit more non-linear. And anything that is it'll either be a line or not a line. Does this make sense how like logic works? Like something is either line or not line. So there is a lot of things contained within not linear, like exponential. I saw that right there. Great answer. There's like parabolic forms. There's all these different forms. But it is true that something is either a line or not a line. Like you have to be either line or not line. So because it's what we call complements of each other, either line or not line. So we understand right here what form is. You should have notes like this right here, where you put that we either have line or not line. I'll keep going back to this right here and adding in more notes. These are the notes you should be taking, that the form for something is either line or not line. Now, I want you guys to tell me, start putting in the chat for direction. There'll be 3 directions. That's your hints. Oh, we got it. Positive, negative, 0. You guys got it. So we've got like positive, negative, and then like this is like neither. It's like it's not really well described by it. These are kind of shorthand notes. We'll take a look at the longer notes. But the direction of something is either this one's negative. I'm gonna fix the slides. Gotta remember. So I did this so perfectly. I had it perfect. So I have to make this bigger now, I think. And so, there we go. Okay, don't like it being off the screen. Okay, got to fix stuff on the fly. Got to get good at that. And then remember how I have it set up each day. It's part of it too. This one is negative. This one right here is also negative. Well, it's just this one right here is not so linear, but its direction is what? Positive, and this one's kind of a neither. That one is a neither right there. Does that make sense? Like, we'll do. This is Rainbow Pen. Rainbow Pen is here. So we've got positive, we've got negative, and we've got neither. Does that make sense? This one is negative right here. So that is negative. That is positive. That is kind of like, it's not well described by positive or negative. So now we understand what direction is. Direction is probably one of the easiest ones to understand. Strength is a little bit more tricky. Rainbow Pen. So strength is a little bit more tricky. Here's the note you should have for strength. The note you need for strength is strength measures the vertical scatter of the points around the form. First person put that in the chat gets 50 points. You ready to hear it again? Strength measures the vertical scatter of the points around the form. Strength measures the vertical scatter of the points around the form. Strength measures the vertical scatters of the points around the form. Justin, amazing work right there. Justin, you guys got it. So strength measures the vertical scatter of the points around the form. Boom. And so what does that mean? What are you talking about, Brian? Okay. So when we look at this right here, we can see its form. It has a linear form to it. Does everyone see that a line goes through this? It's a somewhat, I mean, it's good linear. I've seen a lot of Scatterplots, and this one did a good job. It's a good linear form. So the vertical scatter is this. Let's put it the Rainbow Pen. We got Rainbow Pen. We're going to use Rainbow Pen. Rainbow Pen doesn't, you have to do Rainbow Pen sideways and you see the rainbow. If you do it up, down, you don't see it. So the vertical scatter is this. This is vertical scatter. Does that make sense? So if I were to redraw this plot over here, and I were to put the points like this, what would go through this new plot? What kind of form would go through this new plot? What kind of form would go through this new plot? Any ideas on the form that would go through this? Any ideas? What goes through that? The new plot I just drew, what would go through it? A line. It's a linear form right there. Devin, nice job. So we got right here, it's a line going through it. That's a line. Microphone. Get out of the way, microphone. There we go. So now I want you to look at the vertical scatter here. You can do it up, down if we want. So now it's tighter around it. It's stronger. So the strength of this is pretty strong. But let's look at some examples here that make it a little more tricky. Is this strong or weak? Who knows? I want to see in the chat. Is that strong or weak? Strong or weak? What do you guys think? Strong or weak? No, we're going to take a poll on this. We're going to do S or W as the poll. And so get ready to take a poll right here. And so let me edit this poll. So the options are S or W. So don't answer yet. S for strong. You'll see the poll star in the chat. And there we go. I like seeing how quickly I can do these because then I try to use them. Okay, so the answers are S or W. The poll should be started right here. You should see it appear in the chat. And let's see what people are saying. So remember, vote S, vote W. Let's see. So let's see how the poll goes. Strong or weak? Is that strong or weak? Oh, very interesting. So let's see. I might ask. Okay, so let's close the poll. Let's complete the poll. Okay. So we are going with, it is weak. You'll see in the chat here in a second. So around 2/3 of the class think it's weak, and it was a 50-50 shot. Oh, I might be looting something. So with this right here, let's take a look. I got to move the camera. It's driving me nuts. Okay, so so with this right here, let's take a look at what's going on. It is actually very, very strong. Because how do we measure strength? How do we measure strength? You got it, Keaton. How do we measure strength? How do we measure strength? Any ideas? Strength is measured by the vertical scatter. So I want you to look at and see if you see any of the vertical scatter, if you no longer see the thing behind me. The vertical spread is like this. What changed between graphic 1 and 2? The strength is still about the same, but what changes between these two graphics? The strength is still the same. The form. And the direction, yeah, and the direction too. Graphic 2 is kind of it doesn't really have a direction. It's like positive and negative, and it's a nonlinear form. It's parabolic, but it's still very strong. Why is it strong? Why is graphic 2 strong? Because it's tight around the form. The vertical scatter is how tight it is around the form. Does that make sense? So you could do a weak parabolic. A weak parabolic would be something like this. Because these points have more what around the form. This would be a weak parabolic relationship because these points below it right here have more what? More scatter, more spread, more vertical scatter. Does that make sense? They're more spaced out around the form. So you can do a weaker linear form. So this is linear, positive, and very strong. Let's below it, let's draw a weaker linear positive. I'm going to draw the red line. So you can make it weaker by taking the points and giving them more spread around it. So now this is a very, very weak positive linear. It's weak positive linear. So does everyone see how I'm changing the strength of it by making the points go out wider around the form? So the form has nothing to do with strength. The direction has nothing to do with strength. The strength is merely how tight it is around the form. And so all of these up here are strong right here. They're strong. More spread equals weaker. Exactly. And what's the weakest possible relationship? This. Now you have to be careful. And here's something I like to show. Is if you draw around this, I want you guys to tell me what this looks like. First person in the chat, you only have to type something very quickly. First person gets their 50 points. What does that look like right there? First person. Who knows? They're saying, I'll take circle. I think it was Claire said, or Devin was first to say circle. You know what answer I was looking for? Well, you got to say the other answer I'm looking for right here. Who knows the other answer I'm looking for? Everyone's saying circle. It does look like a circle. I'll agree with that. Okay. Nayland, I got to give you a 50 for that. Who's got the other answer I'm looking for? I did have a breakfast biscuit this morning, so I'm actually not that hungry. I was like, I'm going to eat. That's a smart idea. How about that? Does it kind of look like that? Who thinks it kind of looks like a 0? You featured it. It looks like a 0. That's going to be a very important thing for us to know right here, that it looks like a 0. Since it looks like a 0, maybe that's telling us something. But there's something else we need to know. We need to know this. That when we have strong relationships, and it was a student who taught me this, these strong relationships, when you draw around them, look more like a what? Like I'll draw 2 strong relationships over here. They look more like a what? Any ideas? We're saying 1 in the chat. You got it. It looks like a 1. That one also looks like a 1, but this one goes downward. So that would almost be a negative, and this one would be a positive. Wait a minute. This is cluing us in on some info right here. We're learning some stuff. So it's almost like that one's closer to -1. This one's closer to +1, and this one's closer to 0. But we're going to see something weird right here. We're going to see something very weird. What's going on? So let's go right here and do the following. And let's draw around this. Now, this one doesn't so easily draw around. But what does that look more like? What does that look a little bit more like? Any ideas? What does that new one I just drew look? It looks like a 0. And you know what the correlation is on this? We're talking about correlation right now. So tell me, does this graphic I've highlighted have no relationship? Does this graphic I've highlighted have no relationship? Yes or no? Wait. Oh, that's a weird way of asking it. That's so weird because it's a double negative. I'm going to answer the way I asked is so weird. It actually has a decently strong relationship. The relationship is just not linear. So it actually has a decently strong relationship. The relationship is just not linear. Does everyone see it? There's some sort of relationship. It's just not linear. And how can you tell how strong it is? If you want to see how strong this is, you need to look at the vertical scatter. I knew I'd erase that. So let's look at the vertical scatter of this. And so we draw the relationship through it. And then you can look at the strength by seeing how vertically scattered it is around that. And it's pretty tight around it. So it's pretty tight around the parabolic form. But what do you think correlation is meant to measure? Only forms that are what? Correlation, as we generally use it, I'll show you a new one at the end here. Correlation, as you generally use it, is meant to measure a linear form. It's meant to measure linear strength. So the idea of form, which is, I think, one of the first things we have on here. So strength is vertical scatter. What is strength? Strength is simply vertical scatter. Vertical scatter. Microphone's in the way. And unusual features is really just outliers. Oh my gosh. We'll talk about unusual features in a second here. It's big important things to know right here. And form is very important because when we talk about something having a linear form, it can be strong around the line or not strong. It can be nonlinear forms. So here's a linear strong. This is strong linear, strong parabolic, strong nonlinear. Parabolic's nonlinear too. And those examples we did here. Outliers. I think you guys know what outliers are. Now I want you guys to tell me, is it weird for someone to be 85 pounds? Is that weird? Is it weird to be 185 pounds? Is Brian weird? I'm like almost exactly 185 these days. Is Brian weird? No, it's not weird. And I want to say this. When I say weird, it's like, I say it because I talk about myself, so I can make fun of myself all the time. But Devin gets it. Based off my height, it's not, and I should say unusual. That's a better word to use for these things. When we talk about is something unusual, outliers are things that are unusual. So think about this. I would say it's unusual for somebody to make a 40 on the test who has 100 on the quizzes. It doesn't mean it doesn't happen, but making a 40 on the test and having 100 on the quizzes is unusual. You scored lower than I would have expected you to. So this person right here, who weighs 185 or so and has a height of around 5'2", is unusual because their height is a lot lower than I would expect it to be. And they're going to have some sort of impact on this line. So the line, it's close enough. But they are a lot lower than we would have expected them to be. We would expect them there. So they're far away from the linear form. Yes. So that's just, there you go. That's exactly it's, and it's not like bad or anything. I don't want to be like, oh, that's bad, but it's unusual. Does that make sense? Like you're far away from the form of the line. So when is something unusual? when it does not follow the bivariate relationship. Does everyone get that note right there? Something is unusual when it does not follow the bivariate relationship. Something is unusual when it does not follow the bivariate relationship. Good stuff right there. And so unusual does not follow bivariate relationship. And that specifically applies for scatterplots. So if you talk in the univariate relationship, this person right here, if you just say like how much this person weighs, they are not unusual in their weight. And like I myself am not unusual in my weight and my height weight combination, because I have kind of on, it's funny. You look at all these things and I'm actually like, it's like you are 10 pounds overweight. And I'm like, I'm 6'3", 185. I'm 10 pounds overweight. What's going on in the world? I don't know, all these, whatever. Don't look up charts. You'll be confused. I am all the time. Something is unusual when it does not follow the bivariate relationship in a scatter plot. Great job, Claire, right there. Something is unusual when it does not follow the bivariate relationship in a scatter plot. Yeah, I know. It's hard because of the way like there's so many factors that go into it. So many factors. It's so confusing. This one, I've never put this on a test, so don't worry. I'm going to do it quickly here. So would low outliers still fall into percentiles or high percentiles? Think about Jared. Great question, Jared. So a lot of times when they, if you were to talk about somebody's weight, you would probably standardize a lot of the things, or you would control for them. So when I go to the doctor or something and they look at my weight, they're not going to be like, oh, you're almost 200 pounds. You're so heavy. They're going to be like, for your height and for your age group, this is, where you should be at. So they try to remove the other variables. So they're like, you guys are cracking me up in the chat. So they try to control for the other variables. They try to remove variation, which is what statistics does. So they're like, for your height and for your age group, here's your percentile. Does that make sense? It doesn't make sense. None of these charts make sense to me. Don't look at them. Don't look at them. Don't look at them. No, you're fine. Don't worry. I'm if it makes you feel better, just remember Brian's like 10 pounds overweight. So I'm even more. So don't worry. Just don't look at them. They'll scare you. It means he's like, who made up these things? Awesome. And you're right. Pivot tables and charts can control for that stuff. The tables. Okay. This slide right here, we don't have to do too much on, because I'm not going to put this on the test. That's why. What it is showing you right here is there's actually more variation within the data. So we have here where there's two processes happening. So you've got machine A and machine B, and you actually have stronger relationships than you would think. So you would think that the strength of the relationship is this, but when you control for machine A and machine B, what you notice, or supplier, machine, supplier, same thing, is that they're tighter around it. So if you notice right here, we have a weaker strength, which is I want to go back to talking about strength. Then when you can control for machine, it makes it tighter because each one's actually tighter around the form. Does that make sense to everybody right there? Did I miss a question? Sorry, I've got this covering the thing. Is this class going to go to noon? You bet. We always go to noon. You got it. And we'll probably do some work at the end. So we're going to go to noon, and we'll take our 5-minute break because we're going to get a 5-minute break today. We got it. So there are positive correlation right here. This is positive, linear, somewhat strong, strength, direction, form, unusual features, all that good stuff. Pretty easy topic right here. And we're going to go into another one of Brian's famous pet peeves. I like to say we have the explanatory variable and we have the response. Now, I want you to notice something here. Explanatory variable. That's rainbow pen. I didn't want rainbow pen. What do you think explanatory variable goes with? Let's see in the chat. Explanatory variable goes with what? The explanatory variable goes with what? Your x. Explanatory. What do you think explanatory variables like to do? Explanatory variables like to do what? First person in the chat who uses this word gets the 50 points. Explanatory variables like to what? I think Claire. I think I've already given Claire points, but Claire gets points. And who else? They explain Justin. I already give Justin points. And so Alyssa and Devin too. And Alyssa, you're the first person to get points right there. Trying to make sure I find some new names right there. Explanatory variables explain. Now, when you ask a question, first person to put this, what do you usually ask when you want to understand something? What do you usually ask? What do you usually ask? Like, think of a 3-letter word. Who's got this one for 50? Yeah, William, you got it. William got the 50 right there. Why? Why is this happening? Go back to all of our original graphics. If you go back to all of these right here and you look at what's on the y-axis, maybe we want to know, why do people get certain test grades, and maybe the class they're in explains it. Like, we've got test grades on the y-axis right here. Does everyone understand this is your test grade? And it's like how high and low it is right there. And then on the x-axis, we have your class explaining it. Over here, you could say, why did you get a certain grade on the test? Well, maybe it's your quiz grades that explain it. So on the bottom x-axis, it would be your quiz grades. Over here, you might ask, why do people pass or fail the test? And maybe it's the section they're in. But if you notice, we talked here on this graphic about grades because grades were quantitative. What was your grade in the class? Like, why did you get a certain grade? Maybe it was the class you're in. But on this graphic, we said, did you pass or fail the class? Because that's what we want to understand, and it's categorical. Is that preacher saying why? Oh, I don't know that meme, or I don't know that thing. Does everyone understand the small, subtle differences in what goes on the y-axis right here? Does everyone understand how each of these graphics have a why question? Why did you make a certain grade in the class? Maybe it's your quiz grades that explain it. Why did students make a certain grade? Maybe it's their section that explains it. Why did people pass or fail the class? Maybe it's their section that explains it. If you notice, I said section again because in both of these instances, I can use a categorical variable down here. So the type of variable will create a different display. And truthfully, this right here, these are all your major bivariate displays. Make sure to have a note right here. These are like the 3 key bivariate displays. There is one I didn't put on here. There's a secret one. There's this one. Don't look at that. It's logistic regression. I never said that. I never told you what logistic regression is. Run away. Okay, so we know all the different combinations. We don't teach that in this class. So I didn't write it. Don't pretend. Don't write it down. Don't. It won't be on any tests, so you don't need it. Okay, and let's take 320 with me. So we have here the response, the y variable. It's what we want to understand. It's the variable of interest. I think usually people call it the independent variable. No, it's the dependent. I just hate those words. So listen. Did I miss a question? Oh, like you guys can give extra credit to someone who doesn't have it. We'll do that today. Wacky Wednesdays, you guys can do that. You guys can give people the extra credit. If I give you the extra credit, so I'm going to keep calling out those first names so you get to be the hero to people. You get to be the hero if I call out your name. You get to tag somebody, and then they can tag somebody. We play the game of tag when we do this. So make sure you're in the chat. So, okay. I'll let you guys do that on Wacky Wednesdays. Okay. So the response variable y is what we want to understand, the explanatory variable x, and they go on the axes. Now, once again, you'll notice right here that in other disciplines, they'll call the response I just want to make sure I get it right. The y variable is the dependent, and the x variable is the independent. I hate that terminology. Yeah, I know. I just like calling it the response. It's what we're interested in. It's what we're trying to measure. It's the response. Like, if you are in a lab and you're trying to see how quickly something burns or something like that. You're trying to see how quickly or the depletion in this. That's your y. It's the thing you're recording. It's the response you're measuring. It's the y. Dependent, independent x. Yeah, dependent is the y. I hate that term. It's like, yeah, in the equation, you see how it works. I just like calling it the response. It's what we want to measure. And then x explains it. Makes sense. X is explained. That's what they do. We see a time plot right here. Here's your specific note right here. Get ready for your note. Have your pen out. Time plots are special case scatter plots where the x-axis has a time variable on it. Time plots are special case scatter plots where the x-axis has a time variable on it. So time plots are scatter plots. All time plots are scatter plots. I agree, Sarah. Way easier. So all time plots are scatter plots. Every single time plot is a scatter plot. But when is a time plot a scatter plot? Down here, when there's a time variable on the x-axis. When there's a time variable on the x-axis. So this is a time plot. It's also a scatter plot because all time plots are scatter plots. Nice job right there. You got it. That's a time plot is a special case scatter plot. It's like I'm human and I'm also male. So males are special case humans. Not like I'm special, but it's subset within. I guess it's just that males are a subset of humans. Time plots are a subset of scatter plots. Cool. This pretty much won't be on the test. You can do this. And actually, you know what? They're doing this a lot for a lot of the fun thing that's happening in the world around this time that shall not be mentioned. They're doing the trend in it, like the 7-day trend, so we can do like a smoothing pattern. This won't really be on the test that much. One of the great things about being in class is you know what notes, you don't have to really review much. And knowing trends is not something we're really going to cover much in this class. So don't worry, the trend stuff is not throughout there. I'm missing just the edge of this graphic. It's just a 15-day moving average. If you notice, it kind of shows you a smoothing pattern through it. So that's, if you look at some of the graphics people are putting out there, you'll see a trend line and it'll do a moving average. Cool. I mean, it's very useful. It's very useful. But yep. Oh, you know, I'm talking about Kyle right here. Very, very useful. Used a lot in time series data. And so I think we mentioned that right here. We've got some courses. And Dr. Lee, great teacher, is teaching BAS 475. Is that the right number? I think it is. So I'm basically promoting a few classes. If you are in a discipline that uses like time-ordered data, time series is a very, very important class. And then Charlie Quick teaches this class. He's absolutely amazing. So is Dr. Lee. But Charlie Quick has been teaching this class. He literally taught me this class, which is starting to sound like that makes him old because I'm getting older. But he taught me this class in 2006, I think. And it's a class all about statistical process control, which, you know what? First person to tell me, and I'll give you a hint. Can I make this way, way bigger? Cool. Oh, no, I should not have done that. Good. Right here, 99.7% of the data is expected to fall within the upper and controllable limits. 99.7% of the data is expected to fall within these control limits right here. So within those control limits, we expect 99.7% of the data to fall within those control limits. So how many standard deviations do these control limits go out? How many standard deviations do these control limits go out? When you make this chart, you got it, Justin, right there. Tag someone in the chat. I think, Justin, you might have it, but Justin, you can tag someone if you've already got the points. Remember, if you get the points and you get them again, you can tag someone. You can only get 50 points, but you can help your friends and everyone in your classmates get 50 points. You guys know it's 3 standard deviations. So you can kind of even say, what's the standard deviation for the process? And I swear, the way we did it might look weird. It looks to be like the standard deviation is something like 4 or so. And so we can kind of measure what's going on with this process. This is the mean of the process, and then this is 3 sigma limits above it. So what you're learning in this class, and look at this is an outlier because it's more than 3 sigma limits on the outside. And then you can see how often things are above or below the mean of the process. If you are nursing, things like this is very important because what you have right... So what we have right here is we have points outside of here would be outside of 3 sigma limits. They'd be outliers. So you're even doing a review right now that we have a point that is more than 3 standard deviations away from the mean. If you were to give this a z-score, someone give me a guess of this z-score. I'll give you points. Give me a guess of the z-score of this point being highlighted right here. Give me a guess of the z-score on this one. Give me a guess of its z-score. Any ideas? I like her there. Skylar, you got the points. You are right. About 3.3. Nice job because it's more than 3 sigma limits outside. How about this one right? No, let's go to this one right here. What is the z-score for this one right here? Who knows what the z-score for this one? Here's a hint over here. What's the z-score for this one? There's a hint right here. What is the z-score for this one? You got it. Skylar again, and Tyler's new. I'm going to give the points to Tyler. Wait. Josh got the points. Sorry, Tyler, you get the points too. I called your name. You got them. Josh, you got the points. Josh, good job. And then what is it's 0. Anything, this is going to be like negative 0.2. I think people are seeing it, that this is the mean of the process. And so now we're using our knowledge from this class for another statistical class. So it's like, okay, this makes sense because things below the mean have a negative z-score. And if we know this is 3 sigma limits, then this would have a z-score that is lower than negative 3. This is going to be like a z-score of like 2 or something. I swear those red lines should be in a different spot. So I'm mad at the graphic. So we use these things all throughout. There's time plots again. Has time on the x-axis. Cool. Kentucky Derby data. Histograms are univariate quantitative. So a histogram is a univariate quantitative display. Where's my pen at? Where you at, pen? and this is bivariate quantitative. The axis on it, so a histogram is only univariate, and a scatter plot is bivariate. So you can see that times in the Kentucky Derby actually had a sharp decrease, and it's actually due to two processes. The Kentucky Derby actually had a change in the length of the track. I can't remember when it happened, but there was a change in the length of the track. So you'd actually see that better in a process control type thing. So there's, which is when we would use something like this right here with process control over time. So if you notice, a lot of stuff going on here. Horses on roids. Maybe. They're like, yeah, we shortened the track, and they don't tell you the truth behind it. So a big note on this slide right here. Histograms are quantitative, univariate. So they're just quantitative. Scatter plots are bivariate quantitative. So both of these deal with quantitative data, but a scatter plot shown here. And this is actually a time plot because it's got year. So that is a time plot. It's still a scatter plot, but it's also a time plot. It's a special case scatter plot. So does this make sense right here? Everyone have these great notes on these slides that histograms are univariate quantitative, scatter plots are bivariate quantitative, and then something can be a time plot if it has time on the x-axis. I think we are good. It changed in 1896. You're right. Is that when it changed? Oh, so this is they did get faster. Sarah, great job, Sarah. Throw someone some points. If it changed in 1896, then horses have gotten faster. This is a linear trend, not linear. It levels out. It's non-linear towards the end. It's somewhere in the 20s, 30s, and 40s. Whatever they did, they reduced the variation. You can see that the variation reduced because there's less spread, and it went down. I don't think it happens over. I don't think 100 years is how long evolution takes. The change in allele frequency of a population over time. I don't know. I mean, they are breeding them. I guess that is kind of controlled. So, yeah. It's not really by ways of natural selection, but it's changing allele frequency of a population. So, yeah. Good stuff right there. Better healthcare, better taken care of. Yeah. These, you know what? We once again we say this all the time. It's the stats don't lie, the statistician does. And so you guys, these are great theories. So all of the theories we're coming up with right here to explain the data are just theories. They're just ideas. And what we observe is fact. These data points are fact. Your answer to why it happens is a theory. Such as like when we observe gravity, I mentioned this before, 9.81 meters per second is a fact. And then when we explain it via general relativity is the theory. Because general relativity could be wrong. It is not wrong that when I drop something, it falls at 9.81 meters per second. That is observable, measurable fact. But then why does it fall is the theory. So this data over there is observable and measurable, but why are they decreasing is the theory, which is always open to revision. So you go right there. You guys got it? Nice job. I like you guys helping each other out. You guys are awesome. Keeping your classmates engaged. Spreading some positivity. You got it. That's well then here. So Ben asked a question about the world event. So I'll mention that. We'll pause on the screen here in a second. I love when you guys ask questions. Even when I think Ben, were you emailing me about the one student was. It might have been you, Ben. So with those statistics, the problem is this: is that we need standardized ways of measuring things in statistics. We need standardization, which is something you actually do in process control. If you want to understand your process, you need to standardize the way you measure things. That's very important. And I'm not saying they're not doing that, but I did hear, I think the numbers are for the most part pretty good, somewhat standardized, but how do we know certain, I'm not just personal opinions here. I think the numbers are bad. I'm hoping they keep going in the good direction they've been going in. You'll hear me all the time talk about how seriously I take quarantine, stuff like that. I've got a mask. It's all right. I try not to bash on anybody. I went to the grocery store last night and I tried to stay calm. Just I'm just going to respect everybody. So I don't want to be that guy. I don't want to be that guy who's like, yeah, I'm going to do my thing and do my thing well. That's my thing. And so it literally is. So, personal opinions there. And so, with the numbers, So I know, right? Oh, I'm sorry. I'll move on from this in half a second. So I'm going to bring it right back to stats because I don't want to give anyone anxiety. It does give me anxiety too, just so I agree with you. I think, and that's the thing, I just want to make this very clear. What we do with statistics with things like this, I'm trying to bring it completely back to statistics. What we do with statistics is we use the best available data. And what I always want people to understand about this is that the data changes and our theories change. So my pet peeve, another one of Brian's pet peeves, is when people say, oh, but they were wrong. Remember our famous quote. I might even put this on the final. I wish I could. Well, it'd be a bonus question. Maybe it's a bonus. Who knows who's going to get the 50 points for one of my favorite quotes in statistics? Who's going to get one of my favorite quotes for statistics? It's just like Isaac Newton's model of gravity, which it's wrong. Isaac Newton was wrong. That's cool. Oh, Justin, you're right. Justin, you can tag someone with that. I like that. That's my quote. You guys know that one. You might forget the other one. Who knows the other one I like? And then we'll head on to the next topic. The other one, I might have to say it, is all models are wrong, some are useful. All models are wrong, some are useful. So Isaac Newton was wrong. Isaac Newton was wrong, but his model is still useful. Newtonian gravity is still useful. You can still, use it. I mean, you shouldn't, it's wrong. But, so what do you think about, Einstein's theory of general relativity? It's probably wrong. Like one day we might have a better model. So it really applies to science too, that all these models are wrong because they're a model of reality. Reality is, and we're trying to put reality into words and equations. And yeah, I mean, we're trying to understand an equation by words. And so we're flawed. We don't, it's the sloppiness of trying to mentally put something into your brain. All models are wrong, some are useful. Yeah. And so Newtonian gravity is you can still use it, it's still useful, but it's wrong. But I mean, still use it. So that's a very important quote right there. And that's what I would say to the world event. I would say we've got a lot of useful models. We've got a lot of useful information. We've got a lot of good understandings, and the predictions are always going to be wrong. To some degree. Hopefully they won't be too wrong, but we want them to be good. Yeah, you get what I'm saying. Exactly, Sarah, you get it. Hopefully this applies to a lot of your disciplines. That's my goal with these answers right here. So I want you to understand something I always want people to know about science. Science is not about truth. It's about the pursuit of truth. So science is about pursuing truth and never claiming you have truth. In science, you never say I'm right. You say things like, this is what we understand about this. This is our current understanding. This is our theory that explains it. And when you say theory, you're not talking about a guess. You're talking about something based off of fact, based off of observation. And then that observation turns into a understanding of the natural world. So we use science to create these theories. You guys ready? I can't tell I'm a big fan of science. So correlation. Okay. You need to memorize this equation right here. So everyone got it memorized? Do we got some yeses in the chat? Let's see some yeses. Who has this equation memorized? Who has this equation memorized? Anyone? Let's do it. I think Liz. Okay, we're good. Memorized. We're good. No, we're not memorizing that equation. We're not doing that. We're not doing that. But here's something I want you to notice about this. Something I want you to notice is this. When you do a correlation, and there's a few ways to calculate it, the values of x and y are turned into what? This is the only thing you really need to know about this. The values of x and y are turned into what? First person 50 points. Who's got it? This is maybe the only note we need on this slide. Who knows? I'll take that right there from Zulon. We got their standardized numbers, z-scores, because that's what z-scores are. They're standardized numbers. Zulon, great job. Tag someone if you already have your points. But these are standardized now. So z-scores are unitless. Correlation is unitless. Does that make sense to everybody? We're using z-scores here, which are unitless. They're standardized. They mean the same thing no matter what you're talking about. If I say my height is a z-score of 2, it does not matter how I measure it. If I say height and weight have a correlation of 0.6, It does not matter how I measure it. This is in some of your assignments that are due tonight for this chapter. And we'll do some assignments here at the end of class. But your assignments due tonight have material like, let's say we record this in these units. Does changing the units of how something was measured change the correlation? Yes or no? Does changing the units of how something was measured change the correlation? Yes or no? No, it doesn't. Because we're going to turn them into z-scores anyways. It doesn't matter if you record height in feet, in meters, in inches, in centimeters. None of that matters because you'll turn them into z-scores. So it doesn't matter. It's going to standardize the data for you. So you got it. You got it, Jared. Standardized, baby. You got it. Nice job. I love seeing all the random comments in the chat. It's so much fun. You guys, if you wonder why I have so much energy, it's you. Like, yes, you. You got it. It's you guys in the chat giving me all the cool answers. I appreciate it. So what do we have right here? We have height and weight. It does not really matter how we recorded height and weight. I know heights in inches and weights in pounds because we're American. Thank you, Justin. Where is he? Where you at? So, truthfully, Brian's also, you see, I say this and then it'll happen. I'll be like, man, I want to go back to inches again. But I really like the idea of meters and centimeters, but my American raised brain is like, no, feet, yards, inches. These weird twelfths of feet. Makes no sense. But so if I could snap my fingers and turn us to the metric system, I would. But I've lived a long time under the royal system, if that's what it's called. Like Joseph says no. So what do we have right here? We have a correlation of 0.644. So yeah, it makes more sense. It's more logical, but my brain's like, nope. For students, what is the correlation? What does this mean in terms of strength? Okay, cool. So let me pull up a really good graphic right here. I'm going to pull up our #1 site for learning how to do statistics. Not that. Nope. Give me a second. I got to go to the site. That's how we should teach the whole class. I want to see this in the reviews. He just goes to this site and teaches via this site. Let's hop over the screen here. We're on the screen. Okay, cool. So this is Wikipedia, best site in the world. And what do we have right here? We have here different correlations. And I'm going to have to probably grab this graphic. And let's bring it over. Okay, cool. Let's go to Microsoft Word. Let's go to Layout. Let's go to Orientation, Landscape. Cool. Got him. So here we are. And with this in mind, I have no idea what that one is. Levy has got me through college. That's awesome. What is changing in this top graphic? First person, what is changing in this top graphic? What is changing in this top graphic about all of these plots right here? And it's showing you the correlation above it. As you go in this direction, it gets thiser. Strength. Zulon right there. Strength. Make sure you tag someone. You've already gotten some points, so tag someone in the chat. So say to them, you got some points. Give them a tag and say, you got some points. So you're right, the strength is changing. This is our weakest right here. But what do you notice? Why do all of these have a correlation of 0 down here? Why do all of these have a correlation of 0 right here? Oh, Zulon, there we go. Kelly, you got the points. Nice job. Why do all of these has a correlation of 0? Why do all of these down here have a correlation of 0? You can see one behind me. Why? Who's going to got it? Who's going to explain in detail why all those have a correlation? Non-linear, Kyle, you're right. Kyle says non-linear. There we go. The form is non-linear, so that'd technically be form. I would understand shape. Don't worry. Julio's here, everybody. Julio. So Julio knows immediately. So everyone say hey to Julio. I was telling them about Julio at the start. So good to see you, Julio. So say hey to Julio. Julio's he was on the they made it to the College World Series, and he's also played with Texas Rangers in the World Series. So we get some haze in the chat, Julio. So Julio Bourbon is in the chat, everyone. So good to see you. So give some love to Julio right there. Go Rangers. Got some love for the Rangers too. So wait, we gotta everyone. So we could ask Julio a question or two. So let's see right here. Let's see. Julio, what has changed about this plot right here? Well, I'm asking it in too many ways. Wait. Okay, wait. Let's ask the big trick question we put on test 1. Uh-oh. I'll put you on the spot, Julio. So you ready? This plot right here. So let's see. You ready? This plot right here has a relationship or no relationship. The data in this plot has a relationship or no relationship. So the answer is yes, it has a relationship, or no, it does not. Yes, it has a relationship, or no, it does not. Let's see. Oh, there. You guys are so great. Look at them, Julio. They're on track. You got it. No, I put you on the spot. I know. You're like, I already. Yes! Yes! Look at that answer right there. Nonlinear strong relationship. That is perfect. Nice job. It makes my day. You guys know how much I love stats. Nonlinear strong. Exactly. Nonlinear being the form, strong being how tight it is around it, and direction would be neither. But that nonlinear strong, exactly right there. Amazing work. Yes, definitely it does. It's a classic trick question. Now the correlation, trick question. Yeah, fun. Nice, Brian. Ask more trick questions. Correlation is going to be close to 0. We have a new name, Julio. It's Stat Nation. Stat Nation here. No, it's so awesome. And we've had a few people swing by. So I told Julio, I was like, you're more than welcome to swing by. Can a single outlier change the relationship from weak to strong? Claire, that sounds like it could be a test question and something we need to know. Julio gives his seal of approval on Stat Nation right there. And we do have an interview with Julio on the channel, so go check it out. Julio, I'll show you something else cool, and I'm going to answer Claire's question. Julio, we created something called Mega Mondays. It's my new favorite graphic. So here's our Mega Monday thing. So, we need a crab rave for Julio. Julio. We got the crab rave right here. You asked for it, you get the crab rave. You know how that goes. Okay, so I know I'm trying to come up with new things, Julio. I'm trying to make some new fun stuff. So that's what I do in my spare time. So Mega Mondays, my favorite graphic. That's my favorite because it's got my Mega Man doing his thing. Okay, so Claire asked some amazing questions because outliers and merch. So when we talk about correlation, what does the sign of a correlation indicate? I need some people in the chat who's got the 50 points on this. What does the sign of the correlation indicate? What does the sign of the correlation indicate? Who knows for the 50 points? Who knows? The direction, Justin, you're totally right. It indicates the direction. It indicates the direction. Julio, you are awesome. Julio's 100% right. Outliers can do anything. That's the thing we'll be saying in a second. Great job. I love when Julio gets 1,000 points. I'll do it later. What are possible values of correlation? Correlation range between the values of -1 and +1, including those values. So you do inclusive. I think inclusive's got to be I don't write I do statistics. Statistics is not math. I think that's how you do inclusive. If I am correct, that's how you do inclusive, because if I do the parentheses, it's like excluding those values. So brackets, yep, that's what I was thinking. I was like, it didn't look right for a second. I don't write mathematics. I do code. So what if the relationship is strong but it's not linear? This would have a correlation close to 0. Correlation very close to 0. Sketch of a strong nonlinear. We just did that. We're doing it again. We can do a different one. You could do something like this. So this is a very strong non-linear association right here. It's not quite, it could be exponential. But if you notice here, the strength is measured by the vertical scatter. So it's very strong. Sigmoidal. Ooh, that's, Jared, you got some points right there. Sigmoidal, it's one of my favorite words. You said it. That's S-shape. And so this is a very strong sigmoidal curve right there. Strength is just measured by the vertical scatter. And this one is not linear. So it's non-linear, but still very strong. So sigmoid, you got it. QQ, straight enough. No outliers. Oh, see, I should have tested how loud I can yell into the microphone. But QQ, straight enough. No outliers. QQ, straight enough. no outliers. First person in the chat to write it gets 50 points. First three people. QQ, straight enough, no outliers. QQ, straight enough, no outliers. Sounds like it's important to know. QQ, straight enough, no outliers. Claire. Who else? Devin. Who else? Josh and Needy and Olivia. Tag some people if you want. I said 5, but you got it. So if you already got the points, tag someone else, give them the points, and say you got your 50 for today. So we got QQ, straight enough, no outliers. What does QQ stand for? QQ stands for both variables are quantitative. QQ. Both variables are quantitative. What does straight enough stand for? Straight enough means it is pretty much a linear relationship. Straight enough means it's a linear relationship. QQ, straight enough. What does no outliers mean? No outliers mean, I just want someone to break down this whole no outliers thing for me. It means there are what? What does no outliers mean? QQ means two quantitative variables. Why I say QQ, quantitative. And then straight enough means a straight line well approximates the relationship. And then it means no outliers. Hannah right there said it perfectly. It just means there's no outliers. I like the caps right there, so you got the points. No outliers means there's no outliers. So how does one check these conditions? You look at the plot. What does this plot violate right here? Well, it violates not being in the center of the screen. Let's fix that. What does this plot violate right here? This plot violates the what? We've got how tasty a cake is on a 1 to 10 scale and what temperature it was baked at. Now, I disagree because I think if you baked a cake at room temperature, well, if you just had cake batter, that's what I'm talking about. Some cake batter would be amazing. The more you cook the cake, the worse it tastes. I mean, it might make a good point right here. Awesome. So good to see you. Applying it to my job with baseball. Yeah, I was about to say that. So let me say this. Julio, let me ask you one last question, Julio. I totally forgot. But you were just saying it right here. And let's give everyone, we can do it right here. Give one big round of applause to Julio Bourbon. It's like, here in Stat 201 is Julio Bourbon. Huge echo. Wasn't sure it was working. How useful and applicable. Julio sent me a picture of one of the books he was reading, and it was literally going over p-values. And this is all baseball and everything. You think about Moneyball and all these other things. And Julio's been so awesome, like helping out students and everything. Like he's a huge part of Stats Nation. Like, Julio, do you want to drop your Insta in the chat? I think if students want to follow Julio on Insta, he's man, you just show so much love and support for UT, and that's it. I think that's awesome. Like, useful, and I'm going to be applying all these concepts. Yeah, it's so, and he works for the Yankees, using stats. Like when you were telling me about how they were asking these stats questions, and they're like all these things right here. So they want you to drop your Insta right there. So drop your Insta in the chat, and if you want, follow Julio, or if that's what you do on Insta, I don't know. But yeah. Shoot him any questions, say hey, but thank you for swinging by. You can swing by anytime you want, Julio, and it's always a pleasure. And you guys, Vol for life. I was wearing my shirt. I think it was, maybe I didn't wear it yesterday. No, I wore I think I wore it on the weekend. I got my VFL shirt, my NFL but VFL shirt, so that's one of my favorite shirts. So I like it. Vols help Vols, and Vol means all. That's my two favorite sayings probably. Vols help Vols, and Vol means all. Not a big fan of Big Orange, Big Ideas. It's just kind of like trite. I like Vols help Vols, and then you think about it, Vol means all, because we help all. That's what we do. Vols help all. So, because everyone's a Vol. I mean, we are Vols because we're here at UT, but we help everyone. I really like that. Yeah, Jared, that's awesome. I like that, Jared. So if you can't tell, this is nonlinear. We'll hop back on track right here. We had some fun, or I'm trying to make some, I want you guys to have these fun, cool experiences. I like that. I know it just doesn't work for me either, Sarah. Go Big Orange. I like Go Big Orange works. It's like that works. That works for me. This is nonlinear. It is quantitative. There's actually not an issue with outliers right here because everything pretty much follows the form. So it's nonlinear. It's moderate. I would say it's kind of moderate. Big Orange Nation. Big Orange, yeah. Vol is a verb. Was not it either. Vol. Oh, was that our saying? I think I heard that one time. How does one check this condition? No outliers. You look to see if there's outliers. How do outliers impact the value of R? So interestingly enough, I'm going to do this. Just so you can see what's going on right here, I'm going to do the dreaded thing. I'm going to bring up R. And let's hop over to it. We're almost done with this lecture. So we're going over here to R real quick because I can show you even better with this how outliers impact the value of correlation. There we go. Cool. Can I not? Okay. Okay. Oh, no. Go to plots. There we go. So does everyone see I have correlation right here? Let's take a look. This is following a line. So the correlation here is what? Since everything follows a line, the correlation is very close to what? Everything follows a line. Do you see it? Do you see the correlation up here? Correlation is known as R. You should have that correlation is R. Oh, 5-minute break coming very soon, Justin. 5-minute break coming very soon. We're almost done with this. So this is very close to 1, and now look at the correlation. Now it's 0. The correlation of these points is basically 0. I could get even closer if I go right here. I want to get it to be exactly 0. It's got to be right about here. Oh, darn. Well, I tried to make it 0. I tried. So close. But look how a correlation that was very positive 1 is now 0. Because now, and now watch this. If I go over here, which is further down and further over, who has a guess of what the correlation will be if I go further down and further over? The correlation that was positive 1 will now be what? The correlation that was positive 1 will now be R squared is R squared. More on that next chapter. R squared is literally R squared. It'll be negative. You got it. And if I go as far over as I can, it keeps going more negative. So wait a minute. Let's try a whole different thing right here. You ready? Let's try a completely different plot. If I were to make a blob of points, who knows what a blob of points will have for a correlation? Like just a blob. Like a blob like that. Put another blob in the middle there. Just kind of make a blob of points. A blob of points should have a correlation very close to what? Oh, I might explain. I'm going to go into great detail. 0. Does everyone see how this is like 0 right here? Now, what if I were to put a point way up here? A huge outlier, because this has a correlation of 0. So if I put a point way up here, what will the point do? The correlation will go very close to 1. All of a sudden now, there's a positive linear correlation due to 1 point. Let's put it even further over here. Now it's even stronger. It's creating a linear relationship. We can't really go far down, but guess what? This will make it more negative. You can't see it there, but that's a negative. Well, you can see it. So does everyone see? What are these outliers doing? Outliers are kind of dictating everything. You could have a relationship that is negative. So this is a negative relationship. We could do one that's kind of like negative moderate. Does everyone see I'm increasing the vertical scatter and this is going down? Like, it's getting weaker. Weaker means closer to 0. Does that make sense? So when I put a point that's outside the vertical scatter, see how it got weaker? When I put a point that's inside the vertical scatter, do you see it getting a little stronger? See it getting stronger? I'm going to go in the vertical scatter right here, and do you see it getting stronger? If I go outside, it gets weaker. So the vertical scatter, once again, how tight it is around the form controls the strength of it. So if I go way over here, what do you think will happen? It's going to be super weak. I should have said it before I did. You'd be like, did he know that? I did. I was planning on it for it to be close to 0. If I were to go way down here, we might actually get a stronger one because it's actually creating a new form and it's actually strong around it. This will make it positive if I go up here because it's going to make a positive line. That is now positive. So what can outliers do? Let's go back to the notes. So can outliers make a weak correlation look strong? Yeah. Outliers making a weak correlation look strong would just be an outlier like that. That outlier up there can make a weak correlation strong. Can a strong correlation look weak? Yeah, we did that one right here where a strong correlation all of a sudden could be weak because of that outlier right there. Let's make the other outlier a little clearer. It's the outlier, and that's the outlier there. Outlier making a positive correlation look negative. Same example. Positive data. Point down here makes it negative. What can outliers do to correlation? I want to see one word. Outliers can do this to correlation. You can have a correlation that's positive. It can be negative. A negative, positive. A weak can become strong. A strong can become weak. A correlation that's 0 can become change, destroy. Be even more specific. Kind of. I like these answers pretty much. They can do anything. I need like Lonely Island, like anything is possible. That's like, oh my god, is that like, it's like 2003, isn't it? I wonder if people know I'm on a boat. So it's classic now, I guess. So they can do anything. Devin gets right there. Devin, throw some people some points right there. So anything is possible. Anything is possible. Good. Man, they're so good. I love their stuff. So sketch of outlier making a negative correlation look positive. Just go da, 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 and then you put an outlier up here. So, oh, did he really? I'll have to look at that. So we've got 2 more chapters will be done right before 11 today for our 5-minute break. So don't leave yet. Here's another big important topic, which people kind of alluded to earlier. We've got here that correlation is not causation. Correlation is not causation. What link is that, Coleman, right there? Is it him saying it or something? I don't know if you'll drop links in the chat. Click links at your own risk. I don't know, because I don't know what the link is. The song. Oh, really? I didn't know that. So we've got here correlation. I'm so confused. Nice job, Devin, right there. We've got here correlation is not causation. One of my favorite things is, I'll show you the slides here. Okay. Okay. So there's a very famous example. One of the most famous examples we have where correlation is not causation is the idea of shark attacks and ice cream sales. It is true, 100% true, that when there's more ice cream sales, there are more shark attacks. That is a fact. That when there are more ice cream sales, there are more shark attacks. So wait a minute. Should we just stop selling ice cream? Is that what we should do? No more ice cream sales? Someone's got to be saying it in chat. Let me look at the chat. Because it's summer, Gracie, you're right. Gracie and Zulon, throw some people some points right there. So while I get these notes right here, we have because it is summer, that's why we actually see more shark attacks. So it's interesting. I'll draw it here on the slides. It's not that X and Y are correlated. It's not that X causes Y, like Y causes X, or X causes Y. There's actually a variable Z, summertime, that is causing those two. Now, you might say, well, how do you know summer causes ice cream sales? I'll be like, yes, it is a theory. I have a theory that when it's hot outside, people are more likely to eat ice cream. I have a theory that when it is, I'm looking for the notes. There we go. I have a theory that when it's hot, people are more likely to go in the water. And when people are more likely to go in the water, there's more shark attacks. Both of these are based off of theory. Yes, you got me. I don't know it. Why must you tell me this? But the real bad guy out there, everyone knows it, is not those shark attacks and ice cream sales. The real bad guy in the world today is, let me make sure I've got it up. The real bad guy in the world today is actually Nicolas Cage. Because there is a fact right here. It is a fact that when Nicolas Cage is in movies, there are more drowned. And look at that face right there. He knows it. He's having trouble. He's on a plane right now. He's getting a drink. And he's like, when I'm in movies, people are more likely to drown. That's a fact. That is a true statement. That we see a correlation. I know he's dealing with the pain of this fact. He said, I got to stop making movies, but they're too good. You've got, Con Air, Kick-Ass. What other movies? Not the Bees, The Wicker Man. So, and if you don't believe me, just look at that correlation down there. Uh-oh, that correlation is 666. Something is going on here. But wait a minute. National Treasure, The Rock. How did I forget The Rock? I saw that in theaters. So, that is, Skylar is right on that. So, although, let's go back to the main screen here. Although it is true that the more movies Nicolas Cage is in, Out of Shadows, the more movies Nick Cage is in, the more people drowned. It doesn't matter how strong the correlation is. It does not matter. And you know what's interesting? There's going to be a Tiger King movie with him as Joe Exotic. Okay, I have to see this now. What we see right here is the following. Any 2 points would have a correlation of what? If you have 2 points, what would the correlation have to be? If calculable, I should say. Stat person's going to come in and yell at me. Any 2 points would have to have a correlation of these two values. They'd have to have it. So you can't say something have a correlation of 1 causes anything. These are good trick questions on the test. It doesn't matter how strong the correlation is. That never shows you causation. Because you can get correlations of 1 or -1 all the time and have perfect correlation, because 2 points will always have a line and they'll always be on the line. So these 2 points right here in the 2 different graphics are perfectly correlated. They have the absolute most strength they can have because they fit the form of the line they're on. There is the one instance where you would not be able to calculate correlation because there's no variation. Don't worry, I'll never ask that as a test question. But the third rare instance is it's not calculable. Stealing. I like that, Jared, right there. Are there short answers on the test? No short answers. Multiple choice. The practice test is a great example of it. Correlation example, shark attacks, ice cream sales. Fun stuff. How to report correlation. Cool. I don't like that slide. Correlation table. We've got 2 more topics and we're done before our break. We'll come back to a little bit of regression. We're going to do like a speed run of regression. It is on the test. And then we are going to do review assignments for the last part. We're going to do like 30 minutes of regression. It'll be very important. It's one of the hardest chapters on the test. I would suggest waiting until Friday to take the test, doing the assignments Thursday night, studying Thursday, then Friday I'd take the test. So that's Brian's advice to you. Take the test on Friday because we are covering new material tomorrow. Don't just take the test tomorrow. Be like, Friday around 6 or 7, I'm going to take the test. That if I was in the class, I would take it on Friday afternoon. That's what I would do. Test should open tomorrow for those who want to take it. And I'll try to send a reminder like, I suggest taking it Friday. I suggest taking it Friday. Big suggestion. You don't get to retake it. All day Friday. What do we have right here? Everything up to chapter 8. Chapter 8 is a very short chapter, and we literally covered it during chapter 7. You have 48 hours Thursday through Friday to take the test. Chapter 8 is extremely short, and I cover all of it during chapter 7, basically. Yeah, I could do that real quick after this. We got that in the queue here, Ben. Last 2 topics for this is a correlation matrix. So when you look at a correlation matrix right here, a correlation matrix, you do this. You say assets, and you say profits. And this one right here is the correlation, this is the correlation between assets and profits. I'm going to do something right here. Can anyone tell me, if this is negative, what is the strongest correlation? This is a very important question people often get wrong. What is the strongest correlation in this matrix? It's between what and what if that one's negative. What is the strongest? This is a good note to have that I'm about to explain. Very good note to have. And I'll put a note down here at the bottom. And there go profits and cash flow. You are right, Devin. Devin, you are right. And so so the strongest correlation, even if this is negative, is still this. Strength is how close something is to -1 or 1. Now, the reason these don't matter, I know, don't worry, I saw people giving this answer. These are kind of not important, or they're kind of, it's like saying your age is correlated with your age. Because yes, the older you get, the older you get. So when this company's assets go up, or when companies' assets go up, their assets go up. And how did their assets go up? When their assets go up by a 1-to-1 ratio, which is a correlation of, or they're 1-to-1. If it's perfectly 1-to-1 correlated, then it could be 2-to-1 correlated, but have perfect correlation. This is the strength of the correlation, not the degree. Don't worry. I shouldn't have said any of that. But the 1 correlation would literally mean this. If something has a correlation of 1, every point has to be perfectly on the line. So it doesn't matter the slope of the line. The slope of the line, which I was kind of alluding to, doesn't matter. A correlation of 1 would mean every point is on it. Does that make sense what a correlation of 1 is? A correlation of 1 means the line goes up because it's positive, and every point is perfectly on the line. So that's what we see right there in the graphics. Correlation of 1 is perfect linear positive correlation. Now, you could have perfect linear negative with something like, we have one more topic, then we'll do a quick speed run. This right here is perfect linear negative. Oh, no, that's not perfect. It needs to be on the line. So those are perfect linear negative, and this would be -1. And I did them on the opposite sides of where they should be at. That's a good idea. So those have correlations of 1. The other ones have correlation. And the correlation matrix, let me go a little more in depth on it, Neeland. All the correlation matrix does is it takes multiple variables and correlates all of them between each other. So I think I can show this in an example using jump. I'm going to pull up and jump right here. I'm going to make a correlation matrix to hopefully expand upon this. So here we are in jump, and let's open up some data. So if we want to do a correlation matrix, how many variables in this data set can we do a correlation matrix with? How many variables in this data set can we do? First person gets extra credit. Who's got it? We'll probably take our break right at 11. How many variables? Yep, Claire, you're right. If it was flat, if the line is flat, I have a correlation of 0. Claire, exactly. The answer is 3, because we can only do it with the quantitative variables. So there's 3 variables inside of here that can be put into a correlation matrix. So I'm going to go here to analyze multivariate. This is how you do correlation inside of jump. So if you're doing the homework assignments and you're trying to do correlation, boom, this part of the video right here is where you do correlation inside of jump. So remember, when you're doing the assignments, when it wants you to find correlation, this is how you do it, and I'll be doing the assignments later. We click this. We double-click the variables we want. Do you notice how it says numeric? Because we have to put numeric stuff in here. I'll show you that inside of R right after this. You got it. You go right here. You click OK, and what do we get? Notice how we have the correlation between tip and time, tip and age, time and tip, time and age and tip, and age and time. So does everyone notice the correlation between tip and time is 0.03? The strongest correlation here is between tip and age amount. So there's a positive correlation. I don't know if it's statistically significant, very last topic of today for correlation, but this is the correlation between tip and age amount right here, which is our strongest positive correlation. When we look at the scatter plot for it, it's between age and tip amount. It might be due to the outliers. I'm talking about these points right here, like this graphic. It's weird. Look at it. It's got like two it looks like a Y. So that's a weird nonlinear form. So I've got problems with the linear condition. So this plot, I'm talking about this plot I'm hovering over, none of these seem to have good linear forms. They're all pretty weak, and this is although there is a correlation right here, it's this same plot, it's got a nonlinear form. So yeah, something weird is going on right there. It's weird data. Correlation inside of R, to show how to do that, we'll put that right here next. Bring the video back. There's quite a few ways to do it. And one way to do it is if we have our data, so we go right here, and let's say we have X, and X is 1 through 10, and Y is 2 through 11. So these are just, did I sort correctly? I did. And then I'm running the core demo. That's why I didn't do it. Cool. There we go. And now we go right here, and we say core. I think it's core. There it is. And then you put in your 2 vectors. So you just put in X and Y, and X and Y. Oh, really? What's going on? Oh, to finish. Sorry. I said I stopped it. There it goes. And there's the correlation. So, it's giving the graphics error. Darn you, graphics error. Stop being graphical error. Let's go to files. Let's go to packages. Cool. So, there we go. And so that's how correlation can be done right there. There's a few other ways, Ben. Email me if you're stuck on it. Email me soon. Be like, hey, Brian, I'm stuck. How do I get this data in here? But if you have the vectors inside of here, if they're inside of a data frame, you could do something like absum. I've got that data frame here. And so you could be doing this right here and use these, and then it'll get to the correlation. But it's saying there's no correlation. It says it can't. Oh, because this has no variation. Jump, 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 jump. Remember how I said for a moment that if there's no variation within the data, you cannot calculate correlation? So you remember how I said sometimes it's incalculable? So it gave me NA right here saying correlation's not calculable because this variable right here, average weight, has no variation inside of it. So it was not able to calculate it. Did everyone see how to do it in jump? Jump's in the video, and this is in the video. And we've got one last thing. So we'll be done right at 11 with the topics for today. And we covered a lot. We did a good job covering this right here. So the last topic that we need to know about is related to what? 50 points. Who's got it? What does statistical significant means? When I say statistical significant, you say what? When I say statistical significant, you say what? When I say statistical significant, you say p-value, Alyssa, right there. You got some points. Tag someone else with points if they don't have them. So if you got it, you got it. Alyssa, you can have the points and tag someone. So be saying me in the chat if you want to be tagged for Alyssa's points if you don't have your points. So statistical significant is talking about p-values here. Statistical significance is talking about p-values. So when is something statistically significant? When it is not likely to happen by random chance. And what are we talking about right here? Well, when you look at this, you'll see this p-value down here. And this is done inside of Jump. To do this, you go to here, the platform we went to, and then you go to you go to pairwise comparisons. Where is it? Pairwise. There it is. Pairwise correlations. So you go to pairwise correlations, and then it does give you the p-values for all of these correlations right here. So here's the p-values right here. And look, there is only one statistically significant correlation. Is it the first? Is it the second? Or is it the third? Is it the first? You'll necessite the points. The first, the second, or the third? Logan, you get points for the Spanish. Logan gets his 50 right there. It is the second, because this p-value right here. Jump puts a star and highlights low p-values, which low p-values are below 0.05. That's when something is low by alpha of 0.05. So Jump is telling you, Gracie, great job, that is statistically significant right there. So look at this graphic. It's highlighted down here at the bottom. We see that it is statistically significant. Now I'm not blocking it, and it's bigger. So we see that it is statistically significant. But here's the thing. You cannot look at the value of correlation to tell if something is statistically significant. Someone tell me, first person in the chat gets the 50 points. What is the value of correlation for this graphic? What is the value of correlation for this graphic? What is the value of correlation for that graphic I just drew? I got it. It's -1. You're right, Devin. You're right, man. I thought, same man to myself, I was like, I thought for a moment it was 1, but it's -1. I was like, wait a minute. I kind of did a double take. It is -1. Tag someone with some points right there, Devin. So you are right. It's -1. And so this right here is not statistically significant, though, because all 2 points, if it's calculable, will make this relationship. It's not unlikely by random chance. So you can't look at this and say, this is statistically significant because of correlation. To see if something is statistically significant, you must look at its what? P-value. So take a look at this right here, which is, this is all, if you want to read the slide, there it is. P-value below 0.05, statistically significant. What we're seeing is not likely due to random chance. Take a look at this right here. Is this correlation right here, is this weaker or stronger than the last one? Is this correlation I just highlighted, it's the only thing's highlighted on the screen right now, is the new correlation weaker? Is this weaker or stronger? Is this one right here weaker or stronger? It is weaker because it's closer to 0. Does everyone see how this is closer to 0 right here? And thus it is weaker because this is closer to -1. -1 and +1 are the strongest correlations. 0 is the weakest correlation. And so what do you notice, though, about the statistical significance? This new one, not this one, not this one. This new one right here, is it more significant? This new one, is this new one more significant? Is the new correlation I'm showing you now more significant than this one? Is it more significant? It is, because its p-value is water. When the p-value is low, it's more significant. So if you look at this, this has a high, it's still statistically significant, but this one right here is more significant because its p-value is lower. Which of these do you think is more likely to happen by random chance? Do you think this linear relationship right here is more likely to happen by random chance? Or this one with only like 6 points, or 6 points? The one with 6 points is more likely to happen by random chance, or the one with 200 points is more likely to happen by random chance? Which one of those seems more likely by random chance? Getting 6 points to have this correlation, you're right. And that's what the p-value is measuring, is what is the probability of getting this correlation. This is one of the last things I'm going to stare at here. If it is true that there is no correlation, so the null would be that the true correlation, which is rho, I think it's P. Is it really P? is that row, is equal to 0. And the alternative would be that it's not equal to 0. We would reject. And I know I've got P on there, but you know what I should write? I should write correlation. Because I don't want to think people to think I'm talking about p-value. We'll be done in 1 minute. I think there's a few questions. Why isn't it erasing? Oh, what are you doing, computer? So the null can be that correlation equal to 0. And the alternative would be that correlation is not equal to 0. So the null can be that correlation is equal to 0. You'll not need to know this on the test. So I want you guys to tell me, for this, would you reject the null? Is the p-value low? Do you reject the null right there? Is the p-value low? Do you reject the null? I would say the p-value is low. I reject that correlation is equal to 0. I have evidence that correlation is not equal to 0. Is the p-value on this one low? The p-value on this one's even lower, meaning we have even more evidence to reject the null. We're still rejecting it. So I reject that correlation is 0 here. I have evidence that correlation is not 0. These are key words we'll be hearing a lot at the end of next week. I reject the null that correlation is equal to 0. I have evidence that correlation is not equal to 0. Why do I reject the null? Because my p-value is less than 0.05. Where was that 0.05? There it is. My p-value is less than 0.05. I think what I'm observing here is not likely by random chance, and this one right here is even less likely by random chance. I still reject the null for both of them. I have evidence that correlation is not equal to 0. Take your 5-minute break. Let's start that 5-minute timer. I'm going to answer Claire's question here or Sarah's question about nonlinear. Come back in 5 minutes, 5-minute break. Set a timer for 5 minutes.
Okay, 5 minutes and counting.
5-minute break started. So Sarah asked a really great question that definitely, in a good way, goes above and beyond the class. Let me show you, and I'll show you over here, and I'll show you why I love coding. What we have is, and I can pull up a plot in this. I'll do it this way. It's the easiest way to do it. There we go. So you can have relationships in data. Oh, 2 seconds. You can have relationships in data that look kind of like this right here. If you notice, this is like a non-linear relationship. And you'll notice it's kind of got a sigmoidal bend to it. It even goes down at the end. But there's a key word to this. The key word, and we're way outside of our class right now. The key word I want you to hear is monotonic. Think of your favorite band. What does monotonic mean? That this generally goes in what? Think of your favorite band. It might not be your favorite band, but that's my joke when I do this in 320. And then someone says it, I'm like, yes, that's your favorite band, right? And they're like, no. So it goes in what? Close, not one tone, but one something. It goes in one. It's so much better of a joke in person. I'm trying my jokes out because I'll be teaching this class for a session summer. One direction, there we go right there. It goes in one direction. So the word monotonic means one direction. And this idea of monotonic, now you'll notice that linear relationships, ignore the correlation now. Linear relationships, like I'm doing 2 plots here. We've got here a linear, and this is still monotonic because all lines are monotonic, but not all monotonic relationships are one line. Does that make sense? Big brain. So, your favorite band, there you go. So monotonic means one direction, and this is monotonic linear, and this is monotonic nonlinear. So in 320 in the notes, which I think I still have them up, we talk about that. So these are the 320 notes right here. And correlation. There's a matrix. See, look at this, and there's the codes. Oh, you can do so many cool codes. There's Nick Cage, test for correlation, all this fun stuff. There's p-values, and then there's all the like heteroskedasticity, plot thickening. So let me go very on track right here and mention the thing you'll need to know. What you maybe are looking for, Sarah, is if you have relationships here that are nonlinear, there is a way to measure nonlinear correlation. That way to measure nonlinear correlation, yep. Did I finish it? Okay, good, it's finished. The way to measure nonlinear correlation is the following. So I'm going to pull up some data right here. The data, just so you can see exactly what I'm doing. This loads data that is kind of like preloaded into R. It's from a package I have. What's your favorite band? Maybe, do I want to go with like, I'm going to have to think this over. Like Ben Folds is my favorite musician. That's a definite. Then I've got like different genres. Like pick a genre. I'll tell you my favorite band in a genre. Like my favorite K-pop band would probably be Block B. I gotta go some Block B. So, or like Twice. I think Twice. So would be of like K-pop girl groups. K-pop guy groups would be Block B. I mean, everyone loves BTS. Like, okay, Brian's a huge nerd. All respect lost. That would be good. Yeah. Yeah, like if you haven't heard Block B is my favorite. And people are gonna hear some crazy music now. So let's you get to learn all these crazy random things. So they did it. Block B did a song where they spoofed The Dark Knight. If you spoof The Dark Knight, rap, there's a lot of good rap. Like I liked Busta Rhymes growing up and Missy Misdemeanor Elliott. I think that was her full name. Pretty sure that's what she went by full name wise. But Missy Elliott, Busta Rhymes, like I like some like I guess because I grew up with them in the '90s, and then so I'm trying to think. You know, like you just get into certain yeah. What do you? What is? Oh wait, Pearl Jam. Yeah, I guess I am. Like he likes Ben Folds and all this stuff. So, like modern stuff I like The Killers. Trying to think who else I mean, I like a lot of like Hans Zimmer. Oh, there you go. Hey, what's up, Terry? You're in our 5-minute break right here, Terry. And we're talking about Spearman correlation. Sarah was asking about is basketball in the random class. Oh, we got a new thing, Terry. I got to show Terry this. Good to see you here, Terry. Yeah, he did the entire soundtrack of Over the Hedge. We're gonna take another 2. Oh, I hit restart. Okay, we're gonna take another 2 minutes. We got Mega Mondays, Terry. Check it out. My favorite graphic of all time. I keep showing. It just makes me smile. So what you're looking for, I gotta make sure I talk about this. If we were to do, we had too much fun. We weren't learning during our break. We have to learn. We have to learn at all times. We can't take a break. Okay, so margin's too large. Graphic too large. Graphical error. Okay, so now this right here is doing the correlation between height and weight. Do you notice that this right here is mostly linear? Does everyone see this is mostly linear, but it's got a little bit of a bend? So what's going on here with this? I'm talking about the what by saying it's mostly linear. It's mostly what, so I'm talking about the what. It's linear, so I'm talking about its what. It's kind of, it might be stagnation. It's form. Great job. That's the form. The strength is the vertical scatter, and the direction is positive. And do you guys see any unusual features? Someone tell me the values of the unusual features in this plot. Does anyone see some unusual features, and where are they at? Where's an unusual feature? We might have already talked about this person right here. 75, you got it. That person is 75 pounds and 6'3", so they're my height, and they're 110 pounds less than me. I'm over here somewhere. Brian's over here. He's right there. You see, wait, am I? Oh my gosh. Wait, was that right? Yeah, sure. And so we see unusual features down here, outliers, things that are away from the bivariate relationship. Now, here's the thing. You can actually see the p-values down here. This is showing our correlation, or a correlation just as extreme, happening by random chance variation, given that the null is true. What was the null for correlation? Now, this is outside the class a little bit, but what was the null value for correlation? What do we assume correlation is equal to, given the null is true? And this will maybe help review the last topic. We're back reviewing right now, so class has started, and I'm going to answer Sarah's question about what we do. Well, that's the point at which we drop it. Is this making sense, Sarah? I'm going to answer your question too. So hopefully, Sarah, I kind of explain what you would do. What does attach do? It attaches the data frame such that you can use the vectors inside of it. Attaches the vectors in a data frame that you can use them without calling the data argument. Great question, Ben. Great question. And so the correlation is assumed to be 0. Does everyone see how this is centered at 0? P-values need to be less than 0.05. The p-value here is being shown to you. Do you see any values outside of these lines? Like any things that are as extreme or more extreme than this? Who can guess what the p-value is for their 50 points? Because I don't see any things that are outside these lines right here. The p-value for both of these tests is going to be equal to what? The p-value for the Pearson and the Spearman. are going to be equal to what? What? I don't know. Coleman, maybe don't post. I don't know what the link is, Coleman. So don't click links unless we know what they are, because I don't know what that link is. Coleman, let me double check something here. Cool. Awesome. Make sure to say what links are just in case, and make sure we always know what links we're clicking. That's a good thing for everyone to know. Always know. Okay. Sorry, I'm always afraid. I'm always just in case, you know. And always say like, yeah. I'm always Brian's such a scaredy cat. Calm down, Brian. It's all right. Everything will be good. So what we have right here is p-values, and the p-values right here are going to be close to 0. Oh, no. Coleman, don't worry. It's just that, you know, like, here, I'll tell you guys a quick story. We had one time this summer, I modded someone, and they weren't actually a student, and you guys you're totally fine, Coleman. I'm sorry about that. Coleman, I'm giving you your 50 points in case I haven't given it to you. But I modded someone who wasn't actually one of our students, and then they were actually kind of, and Coleman, you've been great. I don't want you to think this is you at all. But they were then like actually like putting down other students and like telling jokes. But I thought like that they were just kind of like friends with them and like making jokes, like fun jokes. But then one of the students told me, I don't know who that person is. Like, and then I was like, oh, so that's not poking fun there. You actually feel, and so there's our other 5 minutes. So I always want to make sure we have, and don't worry, I just want to make, because I'm like, oh no, what if? My brain goes into these what if, and I'll double check. Dustin, send me your email on your UTK, and I'll double check, because I try to double check everybody. So do that, Dustin, make sure, and that's why I always make sure. So Dustin, send me your email on your UTK, and I should start doing that as the policy. So make sure to do it, and we will get you modded up. Sound good, Dustin? Be like, hey, Brian, that's me, and I'll mod you up. So you got it. So, and then I'm worried, like yesterday, Walker came in and I was like, what if someone like made a name of their name? Does that make sense? So, that's why I'm like, what if I mod someone? Does that make sense? I don't know. Cause I'm always thinking of ways you can kind of break the system. Exactly. I'm looking out for Stats Nation. You guys know it. And so Coleman, you're excellent. So Coleman's totally in our class. Coleman, you know what? I just want you to know how much I appreciate that, and just to let you guys know what's going through my head. You guys know I'm always as transparent as possible. Coleman, I'm giving you 100 points. You broke the rules for today in a good way, because I want you guys to know what's going on right here. No, Kyle, we're not doing that. Okay, so let's go directly to Sarah's question right here. What we have right here is a little bit of nonlinear nature to this. And so you'll notice that we get 2 values for correlation. So the Pearson only looks at the what strength of the correlation. Pearson only looks at what strength for correlation. Pearson only looks at the what strength for the correlation. Pearson only looks at what strength. It's the one we covered today. Pearson only measures what strength. Linear. Spearman, which looks like an S. It looks like something like this. It looks like an S. Spearman handles that fun word for 50 points that we talked about. This is outside the class, but it was a good question that Sarah asked. Spearman can handle what type of correlation? Spearman. And I think someone might say it. It's the fun word. It's your favorite band. If you're here during the break, you know your favorite band. Maybe a little sinusoidal. It can do sigmoidal, but One Direction. Exactly. And look at how the data behind my head has this little bit of non-linear at the end. That's why the Spearman's picking up on it a little bit more, because the Spearman fits a non-linear One Direction form to it. So the Spearman fits this kind of bent. It can do this bend that we're trying to do in the data. So you do have these advanced techniques. And Sarah, I can go into more detail about transformations of data, because you can do a transformation on your data to achieve linearity or achieve a monotonic relationship. But these are the kind of 2 classical techniques. And just so you can see why I love coding, I want you to look how little code I had to run to get all of this output. Like, you can start from scratch right here. I could clear everything out of my environment. So this is like, I could have written all this code right here. and then it does all that for me. So I get all of this output right here with the correlations, with the p-values. We actually get confidence intervals for these, and it makes the plots behind my head right here. So I get all the plots showing me everything that's going on with just that little bit of code, telling me all this information. And look, the histograms, you get what we call border histograms, because you can get a histogram for each of the univariate variables. So you have the scatter plot, which is bivariate, and since there's two variables, you get a histogram for weights and you get a histogram for heights. So a lot going on with this. It gives you a very kind of complex output. And that's got it. Cool stuff. No, it's a great question. Really good advanced topic right there. Really good thing, because I wish we taught Spearman correlation in this class. So I wish keep asking. Ben, ask for videos on it, and I might make you a video. I might have some time later today. So I was making videos last week. I want to make more. Say, hey, Brian, I'd really like a video on this topic, and I'll probably make a video for you right there. So great question, Ben. And I don't know how to do inside a jump. I don't know how to do Spearman inside a jump. I've never done it, so I don't know how to do it. So I don't know something in jump. Okay, let's start our last topic for today. Our last topic for today is going to be. Oh wait. I think. Oh, the difference between association and correlation. Someone asked earlier. It's so quick of a speed run. Let's do it. Okay. Okay. Someone wanted this earlier, so we got to put it in the video. We got to make sure we answer all the questions. The difference between, it's a really good question. The difference, this is world record speedrun. You ready? The difference between associations and correlations. Let's fix the speedrun timer. There we go. The difference between associations and correlations. Associations are... Oh, shoot. The difference between associations and correlations. Every single correlation is an association. All correlations are associations. But when you have a correlation, it must be between two quantitative variables. All correlations must be between two quantitative variables. Now, it doesn't matter if it is strong, weak, or anything. It can be strong, weak, negative, positive. It could be non-existent. And then you would say the correlation between these two variables right here is weak, where this one is strong right here, strong, positive, linear. But when do you have an association that is not a correlation? So we'll draw these in red down here. So you could have things like this, a mosaic plot. A mosaic plot is a relationship between two categorical variables, and although these things could have an association, they would not be correlated because they're not QQ, they're not both quantitative. You could have side-by-side box plots right here, like your grades in a test. Oh no, sub 1's the speedrun world record. So right here, we see here that we have two variables, where one of the variables is categorical and one is quantitative, and that is also not a correlation. Oh, we're so close. Those ones in red are not correlations. They are associations. These are not correlations. These are correlations. You must have two quantitative variables. A little bit of fun right there. So it must be two quantitative variables. So do it again. If this is office hours, I would do it again. If it was office hours, I would do it again. We're still during class. During class time, sometimes we move on. But must be QQ to be correlation. You got it. And then to be doing correlation properly, it must be QQ straight enough, no outliers. And then we have a new one coming up here. Plot doesn't thicken. So close but no cigar. I know, we're so close, so close. Let's hop back here to Mega Mondays. It's not Mega Mondays. Go away, Mega Man. Not welcomed here today. It's not Mega Mondays. We're done with this. Who's having fun in class? Who's enjoying their time? Anyone having fun? A single person. If one student is having fun, I've achieved my goal for today. My goal was one student enjoys class. Did we achieve the goal of one student enjoying class? I'll see the chat here in a second. Oh, wait, I can play the Mario music. I probably can't. I need to fix that later today. Yes, I can play the Mario music. We got it right here. Let's click our tabs. Let's fix our slides and figure out how to make these standardized. It's like a rhyme. Talking about Busta Rhymes. 2 seconds. I need to write down these values. Is it good enough? It's good enough. Stat Nation's always having a blast. We got this. Always having fun. Well, fun's over, everyone. Fun's over. It's time for correlation. We're going to spend about the next 25 minutes doing correlation, which will mean we will have about 15 minutes of class time for doing the assignments. So we will have office hours after. We will do assignments, but it's about to get serious. You get infinite attempts on the homework, so don't do it. Don't do regression. I teach a whole class on this. I teach a whole entire class on this. This is my area of expertise. We got some respect in the chat right there. 320, BAS 320. So if you do want to take an additional class on this, which I promise it's not that bad. If you've noticed, Andrew's been in the chat. Andrew just finished 320. I find it a lot of fun. But if you understand regression really well, we will then, and I'm teaching next semester. I'm teaching next summer semester. If you want, you don't have to take any class, but you can take first session summer in 320. I did have, I think it was Raul. Did Raul really go 201, 320, 474 last summer? I know he went 320, 474, but I'm wondering if he went stat 201, 320, 474, and in the course of like 3 months, you think so? I think so too, right, Terry? Like, it was so crazy. So if you want, so good to have you here, Terry. If you want to take 320, and Terry will tell you this, what we teach you in 201 is probably like 2 weeks worth of 320. We go a little bit slower and we go a little more in depth, but you're about to get some major understanding for regression. You say, well, Brian, why are you doing this to us? Come on. Why is there so much you're teaching us? Has anyone ever written the equation of a line in any discipline? I want to see some yeses or nos in the chat. Has anyone ever written the equation of a line? Has anybody? Terry is totally right. Terry gets 100 points right there. Devin's done it. Jared's done it. Thomas has done it. Josh has done it. We've got Gracie's done it. You're right. All these people have written equations. Look at all those yeses in the chat right there. You know what's going on. Yes, we've all done this. Well, how do we use this in science? How can you use this in nursing and kinesiology and pharmacy and chemistry and biology and you name it? Everything. Oh, Jared, I've got some bad news. I'll be telling you more about that in a second. You can do it on the TI calculator. You can do it in Jump. You can do it in R. So let's take a look at that line that you've already been using. You got it, Neelan. Neelan, nice job. Neelan, throw someone some 50 points in the chat. People can be saying me. Neelan already knows a little bit ahead. Great job, Neelan. You know something we're going to do. So here we go. We're going to do simple linear regression, as Terry points out right here. Good thing I ate this morning because these BK burger menu items, we got the bacon tender crisp cheddar ranch right there. Probably. It's got a good bit of chicken. It's got the ranch. It's got the bacon. So you've got all the fat and all the good stuff right there. Man, the BK tender crisp bacon cheddar ranch. Something like that. Darius Rucker of Hootie and the Blowfish. Amazing guy. Got the honor of telling us about the best sandwich ever created by man. No sandwich has ever come close to it. But what do we have over here? What do you guys think this item is? Let's kind of think about this data. What's that item? Any ideas? 50 points first person who tells me what that item might be. Who knows? I don't know. It's got 0 protein, 0 fat. Fries? Maybe not fries. Justin, throw someone some 50 points. I'll take that. Maybe a coffee. I'll take a coffee. A water. So we got Sarah B and Jared. Remember, give someone some points right there. Also, Scholar points out salad. I'll take salad for 50 points. Throw some people some points if they don't have it. So remember, you can throw some people some points if they don't have their points yet. So we see right here, we're understanding what this is. Who wants to come up with what menu item this is? Any menu item that this is? So what menu item is this all the way up here? Any ideas? What menu item is this? Let's trace and look at the numbers. Let's give it context, okay? So it's got 72 here. You guys are going to make me hungry with how many item this is. Hershey pie, maybe. Is that really that caloric or protein and fatty? Like a triple Whopper, maybe? So nice job. The biggest meal combo, royal with cheese. Got some references right there. So the biggest meal combo, Valerie gets some 50 points, and so does Terry. I like Valerie's thing right there. That's like the biggest combo. Like, that's a good way of describing it. Like, this is the most protein, like it's got to have a bunch of meat, probably because meat has a lot of protein, and a lot of fat right there because it literally has it. So it's like the biggest combo. It's like the triple Whopper combo. So that is, it says an item on here, but maybe they record it that way. Like maybe it's saying the menu, like the literal menu. Supersize it. Burger King's like, you can't do that. Like just dump more fries in the bag. They say we're not Five Guys. If you can't tell, I want a burger. You say smash it. They say we're not Smash Burger. We're Burger King. We got the Whopper. Strength, direction, form, and unusual features. When we go back and look at this graphic right here, we can see that this is a somewhat strong. Why is it strong? Well, I mean, it does have some heteroscedasticity. It does kind of change in the strength. So you'll notice here that the strength kind of gets stronger towards the end of it. Does everyone see the change in strength? Who in the chat? Give me some yeses or nos. Does everyone see the change in strength of this? Yes or no? Do you see the change in strength in it right now? Do you see the change in strength? We got some yeses. I was hoping... Yeah, nice job right there, Hannah. Hannah's right. The vertical lines. This is what I was taught by Dr. Seaver to do. You draw around it, and then you start putting your vertical scatter. So you can kind of get some ideas of where it's stronger or weaker. Now, it's mostly linear. This relationship right here is mostly linear. The line does a pretty good job. But if you notice, it does change in its vertical scatter. So it is kind of getting stronger. Now, I know it's tighter, but tighter means stronger. Remember, strength is vertical scatter. Form is linear. Direction is positive. Unusual features, maybe. I mean, it's got some outliers-ish. Elephant trunk right there. You got it. I like that right there, Claire. 50 points. It's a good way. Animals are awesome. What are our 3 conditions? I need to see them in the chat first. 3 people get 50 points. You can pass them around to people. Mary, you can only get 50 points today. But what are our 3 conditions? I need to see in the chat. I have my students yell this. What are our 3 conditions for correlation? What are our 3 conditions? Can you tell we're already reviewing that correlation and regression are connected? No. There we go. Keaton knows it. QQ straight enough. No outliers. Anyone else? QQ straight enough. No outliers. You got it. Neeland and Justin and Jack and one more person. One more. Who we got? Olivia. Great job. Remember, if you already have the points, give someone else the points. We're at that point in the lecture. So if you notice right here, these are the conditions to see if correlation is appropriate. These are the ways we describe correlation. Does everyone hear the difference? This is how we know correlation is appropriate. Someone say me and take Justin's points. This is how we know that correlation is appropriate. This is how we describe correlation. So when is correlation appropriate? When it's 2 quantitative variables, when it's a straight enough relationship, and there's no outliers that are going to drastically change the relationship. How do we describe correlation? Well, we describe it with the strength, direction, form, and unusual features. I should say also that we could put a side note down here. Statistical significance is its own thing. Statistical significance is not... It is true that the stronger something is, the more likely it is to be statistical significance. So they're connected-ish due to statistical power, but they're not the same thing. Strength is not statistical significance, even though a stronger relationship is more likely to be statistically significant. They have some convergence on how the topics, but it's its own thing. So I just wanted to add that in the notes right here. Remember, I do post these afterwards. And yep, so here it is. We are going a little quick right now, I want to say. Tomorrow, we're going to go a lot slower. This is to set your brain in motion for all these topics, because this is probably the hardest or second hardest chapter on this test. So do not leave till noon. Remember, we stay till noon. We start on time, we end on time. So you have heard y equals mx plus b. Who wants... Okay, I'm going to make an argument right here. We're going to do 2 polls. Terry, you can vote on this poll. We've got method 1 or method 2. I'm going to cheat if I don't win the second time I do this poll. Okay. So who wants the whole class to use method 1 for regression or method 2? Remember, you can't vote yet. I'll bring up the poll right here. So we've got method 1 and method 2 on the screen. So wait a moment till I put the options in the poll. We got option 1 and option 2. So we got option 1, option 2. You'll be able to vote in a moment. So go ahead. You'll see the poll start in the chat. What do we got? What do we got? I'm losing. I did say I'll cheat if I don't win the second time we take this poll. So the poll has started now. So go ahead and start voting in the poll. Option 1 or option 2? I mean, I can't stop you from not using option 1. Terry's voting with option 2 right here. Okay, let's take a look at how badly I did. And I need to make the case for option 2. I didn't fight for option 2. I got to fight for it. Okay, let's close the poll. Let's complete it. Okay. I lost. Okay, I got to try to win here. You ready? Here we go. I'm going to try to get the vote higher. Let's do this. You ready? Can Brian win fair and square before he has to... I can't control what you write on your sheet of paper. Why would we use option 2? Why am I going to change the way you understand this? So Terry voted with us too. I want you to look at this B0. I want you to look at it. Stay focused on it. B0 is when X is equal to what value? B0 is when X is equal to what value? B0. Because if X is equal to 0, look at it. Look at the magic here. If X is equal to 0, this equation solves to B0. Does that make sense? Which is the same. That is the same as this B right here because it works the same way. But B0 is when X is equal to 0. What do you think for each how many unit change in X, this equation will go up by how much? Every time, like if X goes, like we do an example right here, we'll say Y hat, which means predicted Y. And then we put here something like 4. And then we put here 2X. So if X were to change from the values of, let's say, like 1 to 2 to 3, every time X goes up one of those values, Y will go up by how much? So you guys see it right there? Jared, you're right. Jared, you got some 50 points. Pass around. Someone say me in the chat and you'll get Jared's points. So if you say me, first person say me, Jared's right. It's the y-intercept because it's when X is equal to 0. Does everyone see right here that with the way I've written this equation right here, Ben, you got those points. Nice job, Ben. So we have right here that for each 1 unit increase in X, we expect Y, which is the Y hat. It's the predicted Y. That's like expected Y. Y is expected to increase, not will. That's a key word here. Y is expected to increase by 2. So I could change this to something like 3. And now, every time X goes up by 1, we see here 7, 10, 13. So for now, or in this new equation, for each 1 unit increase in X, we expect, or we would predict, because this literal thing right here is predicted, because that's what we're predicting Y to be. So I also don't like the top equation because Y is the actual value of Y. Y hat is the predicted value of Y. And I want you to notice what this is. When I put a line through here, everything on this line would be a what? Everything on that line, like it's coming from this equation right here. It's coming from this equation. Everything on this line would be a what? Everything on that line would be a what? Every single thing on that line would be a what? Like predicted value, Neeland, you're totally right. Everything on this line are all predicted values. These are all Y hats. The line makes predictions. Does that make sense? That the line makes predictions. All of these blue dots right here are the whats. What would be the notation for all the blue dots? Every single blue dot would be a what value? Every single blue dot is a Y. The actual value. Does that make sense that this is the actual value of its X? Now, it does have a Y coordinate, a Y, sorry, I was thinking of the next thing I was going to say. That's its Y value. It does also have an X value, but we would say that its predicted value is like 72 grams of fat. That's its actual. And then we have its predicted, which is going to be very important here in a moment. But what makes the predictions? The line makes the predictions. So you see here the Y hat stands for predicted Y. So why do we put a hat on it? Because it's the predicted value on the line. And then the Y is the actual. So don't look at the top equation because it's not formatted the way we do in statistics. But you can see here that Y hat stands for predicted. That is a Y value or an actual value. You got it. Because this is right here. I'll highlight it. This is how much fat it actually had. And then according to its protein, this is how much fat it was what? What I've highlighted right here is how much fat it was what to have. According to its protein, that is the fat it was what to have. Predicted, Jared, nice job, you got it. That is the fat that menu item was predicted to have according to it. And you look, we missed it completely. And why not? I'll tell you the last thing you should know. This is its residual. Its residual is positive. Can anyone using the notation that I have on the screen here write the equation for residual? Can anyone use the equation for residual? Can anyone write the equation for the residual? Why? Close, Jared, you're so close. Jared, you're so close, and I'll tell you a trick to remember it. The equation is, did we not do it first thing? I thought we did it first thing here. I remember writing it. I did. There it is. Go away. There we go. That's good enough. Oh, you can't see it. There it is. So the equation is, Jared, throw someone some points on it. Jared, throw someone some points. If you don't have yours, you've got yours. Residual equals what? Residual equals, nice job, all those people put in the chat right there. Maya, you got some points. I don't think we've given Maya 50 yet. So residual equals actual, and Brooke, you have points too if you didn't get them yet. Residual equals actual minus predicted. Does everyone see it? Residual equals actual minus predicted. I need Buster Rhymes to come in and do the residual rap. We were talking about rap before, and Brian's old. Terry, if you're still here, we need Terry's favorite band. I'm apparently old. It happened. Someone official, non-ironically, I think, called me old. No. Does liking K-pop make me old? I thought that'd make me cool again. I'm just kidding. So we see right here. We've got here the equation. Please note the notation that we have here. Y hat equals B0 plus B1X right here. And it's all right. Yeah. So let me do this. We're going to repoll. You ready? We need to repoll the options. Okay, so we got option 1. Can I win out a little bit? We're going to repoll. Option 1, Space Pen is here to help me. Space Pen is here to help me. So can I win out a second? Can I win out this time? Let's start the poll again. Poll's been started. You should see it in the chat any moment now. DJ Jazzy Jeff. Oh my gosh. Yeah, that's awesome. Oh, I might win. You can vote real. You can tell me if I convinced you. Oh, we've done it. I can't control what you write down, but you might see this sort of notation. And I think the confusing thing to people is that when you look at this, you'll notice that the y-intercept is first right here. Please note that if you are doing this, I don't suggest doing this via algebra, but if you are doing it in algebra, because I know we've learned that way, I learned it that way first also, this would be the b plus m and the x right here. So this is the algebra format up top, and I won out. Amazingly, it looks like I won out. But yes, close poll, complete poll, we're good. Nice job. Yay, thank you guys. I was going to cheat and say I won anyways, but I didn't. I mean, I was able to win. Method 2, yes, it does make more sense than 320. It totally does. It helps out with us understanding what's going on right here. And then if you notice, we have, let me erase that top thing right here, so that way you're not thinking this is why, just because we don't use that notation, so it doesn't make sense right there. And great job on everybody. So I love it. You guys' points are amazing right now. So what we have right here is we have the residual. It says observed. I like to say actual because it makes more sense to me. Remember, I do post these afterwards. So that's the actual minus predicted. Then you can remember residual wrap. Wicka, wicka, wicka. Like a, you know, like the records. If you guys know what I'm talking about. Yeah, I don't know. I got to stop. So residual wrap right here. And residual equals actual minus predicted. You got it. And notation-wise, it's right below it. E is what we call, and Alyssa, I like to write it that way. It makes more sense. And then you just know the actual is the Y value. And then the P is the, and that's not a P value. That's just P hat right there. I doubt that. Okay. That'd be amazing. Oh, man. You know, like, what's his name? Jay-Z is like a genius. That dude is like, you look at like him as a rapper and a businessman. I mean, there's a lot of geniuses in every industry, but he is like that dude. A lot of respect for him. Like really, really smart businessman and really, really talented individual. So I'd love. I what I was thinking is I'd love to hear his thoughts on like data and data analytics and how he uses data. So we need to do an interview with Jay-Z on Stat 201. That's our end goal. I'm so glad Julio did it, but like we're setting our sights. We're putting him at Jay-Z. Like we need to interview Jay-Z to see how he uses data and data analytics. Definitely one of the huge pioneers, or well, not. I mean, I guess you could say pioneers. Like, I mean, he was like just huge in the genre. So great stuff right there. So a lot of respect. Like I have respect for a lot of different industries, and yeah. So Jay-Z, great stuff right there. And I bet you what I would love to do, and this is why I mentioned this, because we're towards the end of class, we're having a little more fun than we usually do. We're always having fun, but I would guess that you think about this. Think about this. Ooh, that's not good. That's not good. Yeah, I agree. Well, I mean, yeah. Sorry. So with this right here, what have I done? Okay. We're back on track now. Okay. When you think about a record being released, you can actually look at the sales of records over time. A record, a song or an album. Why do people get excited when these things have such strong releases? Because you could use a time plot, which a time plot is a special case what? A time plot is a special case what? A time plot is a special case scatterplot. You got it right there, Needy. You're right. Needy, you got your 50 points. I think we've given you points, but you got them definitely. So, and you say someone else say me if you've already got them. Time plots are special case scatterplots. But here's the thing. Do you think the sales of records over time would remain linear? Do you think the sales of records over time would remain linear? Do you think the sales of records over time would remain linear? I'd say no, because that means like think about the first like month of a record sales, it's going to go like this, and then it's going to start to plateau. So the interesting topics that we actually mentioned during the break, which are not on our test, it would be very much like a monotonic relationship. Like it would kind of level off, like how many records are sold total, not like weekly sales, but like total records sold would probably have a monotonic linear to start, but then it would level off. It would kind of turn into a flattened out curve over time. And then we might see some sort of resurgence of a record or something like that. Yeah, exactly. Stocks might surge. That's like called the surge. Ben, amazing answer right there. And then they might have some sort of like monotonic growth, but not stay that strong linear growth. Really? I'd have to look at that right there, Devin. There you go. Yeah, someone might keep that strong trend, stay strong, because if you keep the strength you have at the beginning, boom, you got it. It stonks. You're awesome, Jared. So we've got the residual right here. Let's talk about residuals for a moment. We've got another, I'm going to go till 11:50. I'm going a little bit longer, but we are going to cover assignments at the end. Sorry, I'm doing it towards the very end today, but I want to just do a tiny bit more on this. Everything on the line would have a residual of 0. Everything above the line would have a residual that's what? Everything above the line would have a residual that's what? Positive. Everything below the line has a residual that's negative. Does this make sense? If it's above the line, has a positive residual. So what is the residual measuring for us? The residual, which is quite large for this point, is measuring how much we missed with our prediction. The residual, which is very small for this point, is measuring how much we missed with our prediction. It's just an equation that tells us how far these two things are apart. So think, if you land right on the line, which this one kind of did, now I hate it because that one looks like it's showing a different thing, but if you land right on the line, then you have no residual. The model predicted you accurately. Nice job right there, Hannah. Residuals measuring how much we missed with our prediction. If it's positive, we are above the line. If it's negative, we are below the line. If it's 0, we're right on the line. And look at the equation. That's what it does. It's how much we missed. It's what's left over. It's the residual. So I'm going to cover this topic right here. We'll go back through the notes tomorrow, but I want to point this out. Here's your last notes, and this is majorly important before we start doing assignments. I feel like I have to sneeze. I say that. Let's hop over to the main screen right here. And we're always going to have a little bit of randomness in this class. Let's do it. One of those random moments where we go through and we do just a jump ahead. Oh, I can get my screen set up here in the background. Oh, that's so fun. I can do this. You guys got it. It's one of those random moments. Even a rainbow appeared. Let's do this. Let's do this. Okay. Major important stuff right here. Major important stuff. Okay, you guys ready? Here's your definitions. Write these down. Start writing. Pens out. Here we go. We have here B0. Not capital B. Don't do that to me. B0, which I said no. Don't do that. Intercept. We have when x is equal to 0, we expect y to equal B0. So right here, when x is equal to 0, we expect y to equal B0. So, oh my gosh, Bone Thugs and Harmony, that was, oh my gosh. They were so good. Now that's some 90s stuff right there. Yeah, that's, see my jam right there. We've got here slope. How to get Brian off track. Mention something from the 90s. For each 1 unit increase / decrease, I remembered it this semester, in x, we expect, not with an S, y to, oh, no. I did it wrong. To increase / decrease by B1, and then on average, whatever. I don't write that on mine when I do it. So I'm going to put some very important things in here. For each 1 unit increase in x, and y is getting underlined, you must choose one of these two. Have these written down, please, please, please. And then r squared, I guess the last one. So we saw r, and we saw r squared today. Then my brain stopped. R squared, which is, it's the coefficient of determination, but I don't want to say that. You don't need to know it. I don't want people memorizing coefficient of determination. It is capitalized r squared. Reasons, I've never quite understood why either. The people just write it as capital R squared instead of correlation squared. But let's put right here, let's put a note that this is just this. So I hope that makes sense, that r squared, someone tell me what r squared is in words. What is r squared? R squared is what? What is r squared right here? It's r squared. Justin, you guys got it. It's just, no, so it's not the residuals, because residual in notation is E, but R is correlation. So it's correlation squared. You guys are getting it. R squared is literally R squared. And it is blank % of the variation in Y is explained by the variation in X. And I did want that capital X there. No. Ignore. That's what I meant to click. Ignore all. Good. And so let's do this right here. If you yell at it, it'll do what you say. And let's go right here. Okay. So these are your definitions you should know and have written down. And I'm pretty sure this is your next note-taking quiz, which we'll put due on Thursday. I think I have your next note-taking quiz as just writing down these conditions. So if you did this right here, right now, you just did your next note-taking quiz. Are you guys excited about that in the chat right here? If you did this right now, you have your next note-taking quiz, and you'll be ready to go for tomorrow when we go over this, which these things are on your test. So by following along with lecture, by taking your notes while we're doing class, you're being prepared and you're getting ready. Let's go. You got it. So note-taking quizzes are meant to be easy. If you're taking notes during class, you'll probably have the note-taking quiz. That's where all the note-taking quizzes come into play. You're following along. You're doing it. You get the note-taking quiz. You get another 100. You're good. Just make sure you're taking notes. Great job. Stats Nation. We need like Stats Nation high five or something. I don't know. Like if we'll do a review at the end of class tomorrow, probably the last hour of class will be review. What is the blank again in front of the percent for the R squared? Yes, it's so you can put the percent of variation. So I'll do some interpretations right here. Then we're gonna hop to doing chapter 6. So we need that right there. We need a clap. We need emotes. I know we need some custom emotes. I think I should do that. Devin, let's work on this. Let's try to figure out some custom emotes for Stats Nations. That'd be so cool. We need custom emotes. Like we need a Stat Nation emote, like Stat Nation or something like that. There's ways to do it. If anyone knows, yeah, you guys are, you guys are awesome. I gotta sneeze. A crab. We need crab rave. We need emotes. Okay, that's on the list of things we need. Okay, someone tell me 2 variables I can do regression on, which is regression and correlation go hand in hand. The conditions for regression are QQ straight enough, no outliers. Plot doesn't thicken. So, we got a crab emote. Tip and age, you are right. So I'm going to go here to fit y by x. I'm going to go to tip amount and age. So let's do that because it kind of makes sense. Like somebody's age might explain their tip amount. Like how old someone is might explain how much they tip. There's a bit of a non-linear relationship here. I'm going to interpret these even though it doesn't seem appropriate. Like it's like iffy. So what I'm going to do is I'm going to go to fit the line, which we do in regression, and I'm going to take all of this information right here. Let's reduce some decimals down, and these interpretations will end class. So I'm just making this look nicer. Okay, so here we are. Try doing these interpretations with me. You ready? Try to interpret these values. We're going to go over to our notes and try to interpret these values with Brian by looking at what's in this graphic right here. Okay? So your goal right now is to use this information up here to interpret the values down below. So let's give this a shot. When x is equal to 0, we expect y to equal b0. Here's b0. Here's x. Let's do some help. You ready? This will be a huge help. And we're going to do chapter 6 after this. Sorry we went a little bit long on this today. This is y. It's y hat technically, but the name of the variable is still that. Let me try to make that clear. This is technically y hat, b0, b1, and x. So when age is equal to 0, nice job, Zulon. When age is equal to 0, we expect tip amount to be 4.7. Zulon gets 100 points because you did the full interpretation and you did what a lot of people forget to do. A lot of people, it's all right, people are saying 4.7. That is correct. That is the intercept. But Zulon, I know I'm breaking the rules here. We rarely break the rules, but you got it. That was a perfect interpretation right there. What you did is you plugged in what x was, where age, does everyone see how it just goes right here? Let's show this just visually. This will go where that goes. We expect y, so you know what's going to happen. We're breaking the rules again. We're going to do whoever gets the slope. Who knows how to interpret the slope? Break the rules right now. Get 100 points. It's rare that we break the rules. We do it sometimes at the end of the class. But who's got the 100 points? I need slope interpreted. And then you can probably guess what the next 100 points breaking the rules will be. Review this if you don't know how to do it. And see what we're doing. I'll try to make it very clear. For each 1 unit increase in age, close. For every one, no one's done it yet. I'm going to give some hints. For each, here's where X would go. And please tell me if I missed someone's response. I think no one's gotten it yet. No one's gotten it yet. These are tough questions. If we had to write these out, I would spend a lot more time doing it. This is something for each 1 unit increase in age, we expect. Oh, wait. No. Nope. For each 1 unit. Nope. I'll give another shot. For each 1 unit increase in age, we expect tip amount to. All someone has to do is Zulon. Zulon's got it for each 1 unit increase in age. We expect. No, it's so close. Everyone, don't worry. What do you notice here? Do you see why this is underlined? You could say predicted age. You could say that. We would predict. I might have to give it to Zulon. Zulon, I'm doing it. I'm giving you 150. You earned it. Someone else needs to just copy them. Zulon got the right answer. For each 1 unit increase in age, we expect predicted tip amount to increase by. And you could just say tip amount. You can say we expect tip amount. For each 1 unit increase in age, we expect tip amount to increase. Oh, wait, no, Devin, you're so close. It wouldn't be increase, decrease. You need to select one of those. Why is it going to be increase? Don't worry. This is a tough question. Wait. Here we go. I think Dustin got it. For each 1 unit increase in age, we expect predicted tip amount to increase by 0.06. Nice job. Let's show it again right here. For each 1 unit increase in somebody's age. Why is it age? Because age is X right here. Does everyone notice that? We expect, and what is the Y? We expect, and you can say predicted tip amount, or you can just say tip amount. It works because expected is kind of predicted. So it's fine to say for each 1 unit increase in age, we expect the tip amount. And why is it increase? It's increase because it's positive. You have to choose positive or negative depending on increase, decrease. By, and then B1 has to be put in 0.06. So these values right here line up with these, but you have to replace them with these things right here. You have to input the right things depending. Does it make sense how we plug into these things? Does that make sense? And you could say for each additional age, someone gets older. So you could change it a little bit. There's ways to say it and it's correct, but then sometimes people would say age increases tip. There's weird ways that just don't work. The reason we say expected is because that goes along with the predicted. It's not like somebody will increase their tip if they get older. We just expect it. It's predicted by the line. That's why the expected. Do not say will right there. If these were written tests, I would count off a point for saying will, because we're not saying it will go up by this. We're saying we expect it. Last but not least, one more 100 points. Who knows how to do this bottom one right here? I'm going to erase the helper thing. I'll probably have to rewrite. While I rewrite the helper thing, who's got R squared? Coleman, you got the 50 points. Yep. And I need to mention one more there. Who's got the R squared for the 1.879% of the variation tip amount is explained. You are just crushing it, Zulon. So let's see. Anyone else got it? You're at 200. Why not? This is the break in the rules point. Amazing job. Who else has got it? Who else has got it? Devin's got it. 50 points. Devin, you're at 100. 1.879% of the variation tip amount is explained by. Please notice here that tip amount is the Y. And what is it being explained by? Does everyone see why I always go here and do this? Now, we are going to do this again tomorrow. We are going to talk about this tomorrow, and this is on the test. But I want to point out one last thing. Do you remember that intercept interpretation you guys told me? You told me when somebody is 0 years old, we expect them to tip $4.70. What? That's what we call an illogical intercept. It's all right. It happens. It just doesn't make sense. Because the intercept, of course... Babies tipping. They're $5 for a baby or $4.70 for a baby. Not that bad. I mean, adults don't tip. Model is wrong because all models are wrong, but some are useful. no free. Like taking my. You guys are the best. I appreciate it. I'm sorry we had our break today. We did a lot of lecture today. Okay, you guys ready to do chapter 6 homework and quiz? You guys ready? Chapter 6 homework and quiz. I wanted us to talk about this. We did a lot of topics today. We had some fun. It's time for chapter 6 homework and quiz. Sorry that we're doing it at the end right here. Yep, chapter 7 and 8 tomorrow. I wanted to kind of introduce them today. We probably covered, what do you think, Terry? We covered maybe a little over a third, like 40% of the lecture. Because they know QQ straight enough, no outliers, plot doesn't thicken. All they have to know is, they don't know plot doesn't thicken. That's heteroscedasticity. Which we don't even call it that. It's the plot thickening. It shouldn't thicken. We don't want the plot to thicken. Here. You ready? Speed run of that thing. You ready? Here's the speed run. Where's speed run at? Speed run button. Here's how plot thickening works. You ready? Plot thickening is like this. This is good. This plot does not thicken. This is bad. This plot thickens right here at the start of it. You say to me, wait a minute, you said plot doesn't thicken. Plot doesn't thicken applies that the plot should remain the same thickness throughout. Space pen, you're supposed to be the good pen, but no, you're on the bad one. This is the good one right here. So the plot must remain at equal thickness throughout for the plot to not thicken. Yeah, and residuals. We covered maybe 60, 70%. So we'll talk more about this tomorrow. We'll go more in depth. But, I haven't seen it yet, Coleman. Yeah, don't tell me too much. Don't tell me too much. I haven't seen it yet. So, yeah, no, I appreciate it. I should. My fiance and I watched them together. So, yeah. So, I was like, what is going on? So, I'll tell you, it'll be a while. So, but no, I'm excited. I love some Rick and Morty. You guys know that. Let's do the quiz right here. Let's do it. I like it. The whole class, I'm like, what? I'm like, I'm old. I know wubba lubba dub dub. I thought that's what all the cool kids said. So I'm pulling up my Pearson as we are speaking. So we're going to get chapter 6. We're right on time at the end of class. We are always trying to get these into class to do the last 30 minutes because it is quite a long class. But we got this. There's only 3 questions on the homework. We got this. Oh, we got this. Okay. How is everyone doing? Doing great still? Wubba lubba dub dub. So yeah, I do like some Chelsea and I watched The Bachelor too, and I haven't seen The Bachelor lately. We were really Becca's season and Colton's season, and I watched, and then Bachelor in Paradise with Grocery Store Joe. Yeah, big fan. Grocery Store Joe and Kendall, man, it's my couple. Also, what's their name? No. I know, it is crazy. Bachelor in Paradise. Yeah, me too. Yeah, that's what it means. That's what blah 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 dub dub means. Birdman tells him that. It's like, your uncle or your grandfather, Rick. In my language, it means. Can't do a good Birdman. He just talks very flat. So, what's this? Got it on my board. So, okay. It is time. We got our little bit of fun. Let's do this. This question stumps a lot of people. This one right here, what do we have in the top right corner? I want you guys to tell me, what do we have in the top right corner right here? What is this? What's going on with this? What is this graphic? What is this graphic? What is this? It's a bivariate relationship between 2 quantitative variables. It's a scatterplot. Gracie's right. This is a scatterplot, which is a bivariate relationship between 2 quantitative variables, which means we could fit a line and do a regression, or we could do correlation. This looks to be a somewhat strong negative correlation right here between the batch number, which is like when they make a batch of stuff, they give it a batch number. This came from batch number 5. And it looks like as batch number increases, the number of broken pieces in the batch is actually decreasing. So by the time we get to batch 7 and 8, or batch 6.5, sure. As we go up in batch number, I need to talk to my Pearson about that. As we go up in batch number, we would see that the broken pieces are decreasing. Or maybe it's like time, like we say like hour the batch number was created. Like maybe batch number is recorded at what hour the batch number, because I don't know why it would not be a discrete number. I'll love an integer. Okay, so besides the Brian doesn't quite understand why batch number is not whole numbers, we do see that there's a negative linear correlation between the two of them. All of a sudden now we switch to a, what are these things? What graphic is this? This is review. A lot of these things I'm asking are review questions that you should know. You should be like, oh, that's a blank used to display univariate quantitative data. A histogram, Zulon, you're totally right. That's a histogram used to display univariate quantitative data. And if you look, it's giving us the number of broken pieces. So look right here in this bin. This is the bin for 1, which has 4 observations in it. Let's go right here and treat this as a univariate display. How many times do we have, and I think it's bin for 0. How many times are there 0 broken pieces? Does everyone see how I'm reading this left to right? Because broken pieces is here. How many times are there 0 broken pieces? How many times are there 0 broken pieces? Doot, doot, doot. Careful. How many times are there 0? 4. How many times are there 1 broken pieces? How many times are there 1 broken pieces? Doot, doot, doot. Do you see I'm only reading left to right? I'm only looking at broken pieces. I'm not going up and down, which is another variable. I'm only looking at broken pieces. 4, 3, 3, 4, 3, 4, 3. That's the pattern of it. 4, 3, 3, 4. So let's look. 4, let's take a look. 4, 3, 3, 4. This is only analyzing broken pieces. Do not look at this batch number thing. Don't look at that. That's bivariate. Only look at broken pieces and say, oh, and I'm only going across this 0, not this 0. I'm going across this 0. I'm going right here and I'm saying, oh, there's 4 times where we had 0 broken pieces. Nice, Zulon, you get it. Then right here we go to 1 and I say, okay, there's 3 times that there's 1 broken piece. There's 3 times that there was 1 broken piece. There's 3 times that there was 2 broken pieces. And so that means we're doing this graphic right here. Review it. That's a pretty tricky one. Catches a lot of people off guard. Even I, first time when I had this question, I was like, how do you find the right answer to that? We check our answer. We got it right. Of course we did, because we're Stats Nation. So describe the histogram. Don't look at their answers. How's that histogram look? We should know. Looks like a bread box. Looks flat. How's it look? It looks one form. Hint, it looks like it's one form, not skewed to the right, skewed to the left. Not. It is symmetric. Uniform. Nice job, Josh, right there. That is uniform. Don't look at their answers. If you think of your answers before you answer them, it helps. Because then you check. Because if you look at their answers, it's more like someone reading you a story. But if you think of your answers first, then it's like you're creating more mental pathways. Always try this trick. I wish I could do studies on this, but I believe in my heart, good place to believe stuff, that if you come up with the answer first, you're more likely to remember it and try to, because then if you get the wrong answer, be like, oh, and then you'll reorient your mind. What feature is most apparent in the histogram than the scatterplot? The uniformity of the distribution. That's what histograms show us. Sorry, because scatterplot's going to show us the bivariate relationship. See, I looked at the answer, I cheated. What aspects of the company parent is more apparent in the scatterplot? They've got this negative correlation. So the negative, somewhat linear. It's very linear. That's a really strong linear. So we got it. I think that's done the question. Boom, one question down. We get to one of my favorite questions right here. So here's what we're gonna do for this question. You ready? With this question right here, a lot of people get tricked. And I know where people usually make the mistake on this question. People usually make the mistake on this one and this one. These two, if they ever appear in your graphics. So I want you to look at B. B is the simplest one. I just want someone to take a guess. Don't look at the numbers. Just take a guess of the correlation for B. Don't look at the numbers up top. I want you to guess. I kind of pointed at it. But I want you to guess. I like that. It's like near -1. So B is obviously the most negative, strongest most negative. And please tell me if you type in a decimal wrong, I'll fix it. And it has to be close-ish. If it's pretty far off, I'll be like, good try, and I appreciate it. But because some people email me, and I have said multiple times already this summer, good job, you're really close. But if you enter in an extra decimal or you forget one, and it's pretty clear that you were super duper close, I'll just be like, good job, you got it. So, but it never hurts to ask. Never hurts to ask. I might say no. Okay, let's look at this one right here. This one has to be what? Just tell me from the nature of this. I'm pointing something out to you. This one has to be what? It has to be this. It is that. It has to be positive. And it looks to be, I would say, moderate. And there's only this one right here that's positive, and that's like close to 0. So I don't think this is close to 0. It makes more sense that it's here. You might say, well, is it really that strong? Well, it's definitely not 0. So we go right here. And we go to C, and we put this in, because it's definitely positive, and I wouldn't think it's that weak, because that's like super non-existent. Here's where people get confused, though. I want you to put a line through this. What direction does this go? When you put a line through this, what direction does this go? This one definitely goes what direction if you put a line through it. It definitely is a negative line. That actually eliminates this answer right here. This answer's been eliminated because this one definitely has negative correlation. You might not think that it's as strong as negative 0.487, but apparently it is. They've ran the numbers. Apparently it is. And this one right here, although it is a strong relationship, the correlation is close to 0 because the relationship is not what? This is the one I drew for Julio, and he knew it like this. He'd not be tricked by those questions. This one is not what, so the correlation is close to 0. It's not what? It is not. It's non-linear. You got it. It's non-linear. Nice job. It's not linear. Excellent work. So that one, whoops. We did it. We got it. The scatter plot right here, this is just like the one I did in R. It looks exactly like it. Like, no joke. It looks just like it. And if you notice on this one, the nonlinear correlation is stronger. It's got this bend out here at the end. And we literally are doing the same type of question again. So the scatter plot is not linear. Correlation is not appropriate. And there's not really outliers that much. You might be like, well, isn't that an outlier? It's like, well, there's a bigger problem with the linear nature of this. 50 points. I'm going to give someone an extra 50 for this. Who knows our 3 conditions for correlation and regression? The first 3 are for correlation. All 4 of them are for regression. So you should know all 4 of them. But who knows the first 3? And if someone tells me the 4th, I'll also give you 50 points. So who's going to tell us you get an additional 50? You can only get up to 100, but I think Zulon, I completely broke the rules because they totally knew how to do regression. Close, Jared. That's close. You're almost close enough. I mean, kind of. That's kind of it. You might have that second condition. Oh wait, no. Jared, the end of it's wrong though. But no, good shot, Jared. Jared, you get 50 points for trying first. And it is Nicole who gets the extra 50 right here. QQ, straight enough. No outliers. Does anyone get all 4 of them? The 4th is for regression only, which is the topic we barely got into today. QQ, straight enough, no outliers, is for correlation, meaning both variables are quantitative. The relationship is a straight line. It basically follows it, kind of like close enough. And then no outliers. Plot thickens. Brooke, you got it. Plot, and I like to say plot does not thicken because that's the good thing. We want the plot to not thicken. Not thicken is good. Thicken is bad. QQ, straight enough. No outliers. Plot doesn't thicken. Hey, Adam. So good to see you here, Adam. Yes, like I love the visitors. You having a good summer, Adam? I hope you are. We've got a lot of new fun stuff. We're gonna make some emojis for the chat. We're having a great time. I'm old. My hair is long. That's a thing that's for certain. I'm sure Adam remembers QQ, straight enough. No outliers. Plot doesn't thicken. We remember that. So good. So good so far. Awesome. So glad to hear that. I love seeing former students in the chat. It is awesome. You know who got 100 on the quiz? Yes! Adam, you were in the in-person class where we yelled it out, right? Were you in an in-person class where we yelled it out? And I had you guys yell it, and I yelled at the top of my lungs too. So, you was, yeah. When we do it in class, I literally have everyone yelling it, and I go like, I'm like, QQ, straight enough, no outliers. And so I missed that. You got the hundreds. Nice job. Great work. We got hundreds, got the homework done. That's what we do. It's time now. I feel like I have a little bit of throat in my throat. I swear I'm not sick. I'm just fine. I've just been talking for 3 hours. It'll do it to you. So, let's hop back here.
Are you guys ready for the next one? Should we do the whole next question like this? Let's take some votes. Should we do the whole next? If there's yeses throughout the chat, I'm gonna be shocked, because I would say no to this. I'm just giving the vote. This voice just sounds scary to me when I hear it. I gotta remember to look back at this and crack myself up. What's the chat saying? It's terrifying.
We could do it in radio voice right here. This is like radio voice. Honestly, yes. Someone's gonna watch it and be like, oh. Okay, we're getting the quiz going on right here. So this is having a little bit of fun. I gotta plug in the Mario music for this screen. I don't have availability to do Mario music. So you know what I might do? Let's fix that right now. We're in office hours, so we're gonna fix the Mario music on the screen. Let me look at where it's at. So this way I can have my Mario music on the screen. Okay, let me see where Mario music's at. Mario music is computer. Okay. So let me go back. Let me go to, is it audio input? Computer. Got it. Yeah. Oh, it's still playing Mario music. Good. I saw it was playing. I was like, what's it playing? So, you like the radio voice? We should be able to hear. Are we hearing Zelda now? We now have this sound right here on these screens. So I can now play the sounds on these screens, which I just forget to set these things up because it's a lot, just so you guys can see. I showed you this before, but I've got this whole control panel over here. And that's how I make all my noises and everything. And also I can control the volumes of everything pretty instantaneously. And you like the sound effects? We need more sound effects too. Yeah, we didn't have this. Well, I think I got this at the very end. And then I've had to set everything up right here. So I've been working on this. I'm always trying to improve. And I always take everyone's feedback. So keep giving me feedback. And when I go to Texas, I'm setting up Studio 2.0. So I'll be in Texas with my fiance, and I'll still be teaching at UT. And I just want this to be the best and funnest experience students have for any class they've taken, which is my goal. So I hope you guys feel that way. I want it to be fun, but we're going to learn. I know I'm a little ADD. That definitely comes up in the reviews. So Zelda chat self-opening is classic. I agree. Yeah, thank you so much, Adam. That's awesome. We did this one already, so see, it's got a little non-linear there. We can do this one pretty quickly right here. Do you see how there's 1 batch, 2 batch? Please watch the homework help video a moment ago. So it's 1, 2, 2, 3. So that's 1, 2, 2, 3. That's the pattern. The histogram is skewed to the left to the low, right to the high, whatever way the tail goes. Which of the features? We can see the skew in the histogram, and then there's a positive relationship. So guess what? When we know how to do that question, who here thinks this question right here is pretty easy right now? Can we get some pretty easies in the chat? Who thinks it's easy? Easy? Is this an easy question now? If you know how to do it, if you know how to look at this and tell which histogram it is, easy. That question's easy. That's a question you want in your quiz now. You're like, I got this. I know how to analyze that. We know this one also. We can see that this is a very strong negative. We did this in the homework video. If you're watching this right now in the quiz, go back to the homework video. We can see that that top one there is very strong negative. We can see that this one is close to 0 because it has a nonlinear form, and there's really just no linear relationship. This one's the most negative. So we get right here and we go to that. It's the most negative. And this one right here is the most positive. And the most positive is 0.77. We got the same numbers. It's supposed to regenerate random numbers. McPherson, you're failing us. This one's one from the quiz also, but this one does not follow the linear form or the homework. So the scatterplot's not linear. Q straight enough, no outliers. Boom. Then we go on. Nice job right there, everybody. And here we go. We got the same thing. Okay. This one's a little bit tougher. Which one of these looks to have a correlation close to 0? Graphic A, B, C, or D? Which one of these looks to have a correlation close to 0? A, B, C, or D? Which one of these has a correlation close to 0? B. So the one that's closest to 0 is this. You might be like, but that doesn't look negative. Well, it's really close to 0. It's very, very weak. So that is the weakest. Closest to 0 means weakest. Which of these looks to be negative? A, B, C, or D? Which of these looks to be most negative? A, B, C, or D? Which of these looks to be most negative? A, B, C, or D? I would say C. You're right. So you see, this is the most negative right here. So we're going to put that as the most negative. Which of these looks to be the most positive? This one right here, because it's the strongest, most positive. This is where I think people could get tricked between these two. And this one's a little bit weaker. Do you see the scatter? Strength is vertical scatter. So this one has a little more vertical scatter and a little bit of nonlinear to it. So even though it's a little bit nonlinear, it still is. It still has some linear strength to it. There's still a linear. I don't want to say it's completely linear, but I want to say that there is. We can measure some sort of linear correlation in it. I do not think that is straight enough. I think that we should be better to put a parabolic form in here. We should do a transformation of data to talk about the topic Sarah was mentioning earlier. There's better ways of handling this than using correlation. Also, Spearman's correlation would do a lot better on this. Spearman, as we mentioned, not on your test. It's not on the assignment. It's not on the test. Is for nonlinear relationships. The Spearman would have a much higher value because Spearman measures nonlinear monotonic. So that's got it. We got those done. We have ways of handling the data there. Another one of these. Another one. This one's close to 0. This one's positive. This one's even stronger positive. This one's negative. Can't tell. You should know these things. Wait. Yeah, what's the most negative? Did I get them right? Hopefully I didn't do it too quickly. Got it. Okay. This one's a tricky one. This one's a good tricky one right here. Okay. First time doing it. No. A particularly powerful hurricane, force winds. And we'll do that one here. We'll do that one next, Gracie. We might just do them all because we're already almost halfway done with this. We're doing a great job right here. So we'll make sure we get that one. We'll do that one next, Gracie. You got it. You asked, you get it, Gracie, right there. Great question. So a particularly powerful hurricane, hurricanes forces winds extended 120 miles from its center. The hurricane was a big storm. Cool. And that affects how we think about the prediction errors. Suppose we add 120 miles after each error to get an idea of how far from the predicted track we might find the damaged winds. Explain what would happen to the correlation between this. Okay. So I want you to pretend, does everyone agree that there's a correlation between height and weight right now? Does everyone agree that there's a correlation between, like there's some, like usually taller people weigh more. Does that make sense? That usually taller people weigh more. Yes. So with taller people weighing more, let's say Brian does this, and all of a sudden everyone gains 10 pounds. No, let's lose 10 pounds. Wait, I'm going to take it back. Okay, now everyone lost 20 pounds. I don't know. We can't have people pick what they want. Either way, everyone's going to gain or lose what I say. Does that make sense? Everyone's going to lose 2 pounds. There we go. Not that big of an amount for everyone. So every adult. And so I want you to think about this. If everyone lost weight the same amount, like you're changing all the values by this amount, would that change the correlation? Would the correlation get weaker, stronger, or not change? Everybody's going to have the same thing happen. Everybody loses 2 pounds. Would it change the correlation at all? It would not change it. Because this is the whole z-score thing we were mentioning, that correlations turn things into z-scores. And so when things are into z-scores, they're unitless. It's just about the relationship that they have. We're not changing the relationship between the two variables. It's still the same, like, XY relationship. And then if you were the mean right now and you lost 2 pounds and everyone lost 2 pounds, you would still be the mean. Your z-score would still be 0. So we're going to see that this data would not change. So would not change, and the magnitude of the correlation would not change because the z-scores upon which the correlation would not change. The z-scores, which we see right here, are what control the correlation. So if you were the mean and everyone lost 10 pounds, imagine this, like a much easier example. Let's say the average grade in the class is a 70, and you make a 70 on the exam. What is your z-score? The average grade in the class is a 70. You make a 70. What's your z-score? Your z-score would be what? 0. You're exactly right. Now, Brian says he puts a 10-point curve on the test. The mean is now 80, and you made an 80 now. So I gave everyone 10 points. What's your z-score now? By giving everybody 10 points, you now have an 80, and the mean is now 80. Your z-score is still 0. Does everyone see that just moving the data in a direction, shifting it over, will not change the structure of the data? So we're not changing the z-scores, so it doesn't change the correlation and it doesn't change the magnitude of it. Nothing changes about the correlation. I like this question a lot. I hated it when I first added it, and then I grew to love it. So it's a good question. Talks about how z-scores are related, and it's why I mentioned that in the slides. Don't worry, this is a very, people are like, how do we know this one? It's because it's in the notes. That's why I paused on that one. Was this one Gracie wanted? Gracie, amazing. Gracie, you asked literally the next question. You knew it. Gracie was like, next question's this. You got it. A study examined brain sign measuring pixels in digitalized magnetic resonance MRI of a cross-section of brain IQ, 4 performed scales, the Welsher IQ test for college students. The Scatterplots to the right show the performance IQ scores versus the brain size. Describe the association. I mean, if it is there, it's very weak. Aside from this, this is the only part of it I don't find to be, because if that part of the graphic did not exist, like we just block it out right there, if we were to take this, that is like as weak as it gets. Does everyone see how this looks like? Yeah, if it says weak linear, I'm going to say weak linear. Even then, I'm a little worried. It's just, once again, if that part of the graphic on the right didn't exist, this would be a non-existent relationship. If it looked something like this right here, then that would be like strong positive. Weak positive. Yeah, weak positive sounds about right. It's very weak, though. A weak positive. Yeah, sure. A fairly strong no. It's not strong. It's not weak negative. Yeah. Oh, wait. Oh, is it curved? Wait, it's not negative. Wait a minute. Really? Oh, wait. There were more answers. Oh, man. Oh, like, I didn't even click it fairly strong. I was like, no. I was like, it can't be negative. It tricked me. That's the only way my Pearson wins. It cheats. It's cheating my Pearson. Yeah, and if you heard everything I was just saying, I was like, it's very weak or possibly no association. Negative curved. It's not negative. So yeah, it's that. So how can you eliminate these? Well, it's anything that says negative is wrong and strong is wrong. So this is the only, I wouldn't say moderately weak. I think the only tricky ones are between these two. I would have chosen this to begin with because I was like, I really don't see it. It's very weak. Rewind the tape. Hopefully I was saying that. I mean, I remember covering up the graphic and being like, if it was like this, I would say it's non-existent. And I didn't think it was really there. I think I would have chosen that. But yeah, it's tricky. The only two tricky ones, moderately weak, straight association. Even then, the straight, I think, is a thing they're trying to clue in on. It's not really straight. It kind of bends. It's got a little, there's more of a weak non-linear. If I was to say there's a weak relationship here, I'd say there's a weak non-linear. There's almost a non-existent linear. The linear is very, very, almost near non-existent. Is that it? Cool. I like that question. It tricked me, but I still like it. An organization is looking at cars with model blah, 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 while cars of make yada, yada, yada are stolen least often. So they're looking at, is it reasonable to say there's a correlation between the two types of car a person owns and the risk that it'll be stolen? Who can explain why? Don't look at their answers. Don't look at their answers. They'll trick you. They'll trick you with all those answers. Don't look at the answers. Should we be doing this for car and if it's stolen? Should we be doing this for car and if it's stolen? Who knows? The answer is most definitely. No, don't do it. Don't do it. We've got car type. Don't worry, Skylar. We got you here, Skylar. But we've got car type and if the car gets stolen. Let's go look at our notes. Let's go look at the notes. Here's our notes. We've got car type and if it's stolen. What is the proper visualization for car type and stolen? What is the proper visualization for car type and stolen? What is the proper visualization? You getting it? The proper visualization for car type, what type of car you have, and if it is stolen. Mosaic. And we only do correlation on 2 quantitative variables. So that goes back to the start here. If you can't tell, a lot of these things, great review stuff right here. How much your car costs and if it is stolen would be box plots, Jose, right there. So we could do that with box plots. And you could also do it with logistic. We're not going to talk about logistic, though, because it would be the probability of your car getting stolen by the cost. You could predict the probability of getting stolen, which is stolen, yes, no. And then you could predict based on the quantitative. So I put that one there. It's behind me as a secret. It's not there. It's not there. I promise it's not there. But it's bivariate categorical if we do, does your car get stolen and what type of car do you have? That would be bivariate categorical. No, it's not quantitative. Wait. Oh, I didn't select it. I clicked it. I keep getting afraid I'm going to misread this right here. This looks pretty good. This looks pretty QQ straight enough, no outliers. I know these might look like outliers, but they're look at the Cook's D on them. So, which is a measure of I don't know. Does this indicate that this is appropriate correlation? I'm going to say yes. It shows a linear form. I'm going to say these are not outliers. Let me look at them. Yeah. There's always points that are a little further away. Let me make this very clear. On the test, if we're going to pull an outlier on the test, you will see outliers more like this point right here. We don't try to... You ask a really great question right there, Gracie. We've got a really advanced way of looking at this. Once again, Brian's going to go too far in depth right here. What we need to do is we need to do an influence plot. Oh, did I not get it? Oh, it's Duke Tricatcher. I don't care about that. Cool. The points that are outliers are... What? What are you doing? The points that are outliers are... What? Yeah, I broke it. What is it doing? These are the rows that contain the outliers. So these points over here that have the X's in them are the outliers. You're not meant to know how to analyze this graphic. You want to show me the graphic now? Do you want to do it? R, what are you doing? I updated my R, and I fear that these problems are related to the update. Oh, it appeared. So if you notice these points with the X's, which there should be 4 of them, there's the 4th, 1, 2, 3, 4, or the 4 outliers. What I could do, I'm going to try it. Okay, I'm going to show you where the outliers are at. You ready? Give me 2 minutes to do this. I got 2 minutes. Set a timer for 2 minutes. Okay.
Your timer is set for 2 minutes.
Whoa. Invalid graphic states? Oh, no. Does it... Really? It's not cull? Oh, did I forget? What's going on? Error, object height not found? Oh, because it's capital height. You make one error in code. You make one error in code, and the code doesn't like it. There we go. Okay, cool. Now I gotta fix this. I got about 1 more minute. If else, if row dot names. Oh, what is the argument? Row dot names for survey 10 is contained in. Okay, I think I have it. Is contained in. No, need those values. This is Brian's fun right here. I want to show the outliers. I'm running out of time. That's got it. Cool. There's the outliers. If it's contained in the outliers, and then I want red, and if it's not contained in them, I want black. Argument, invalid character. Oh, I think I know why. Did not end this. I did end that off. Cool. If else, the if else end right there. The if else did end. So that shouldn't end that. That didn't like that. Unexpected comma. If row names is contained in this, then if else. Okay, that runs there. True, false. Give me 30 more seconds. It's Brian's bit of fun right here. Okay, good. It's running it. We want that. Did not read through the comma? Did I have an error on that? What's he mad about? It's not mad when I do this. And then data equals survey 10. Error, unexpected. Oh, okay, yeah, I know what it is. There we go. Okay. So this answers the question, how do you know when something is an outlier? This right here. Okay, I'm back. So if you notice right here, these red points right here are the outliers, and I'm using my code to identify them. So I was able to find the row numbers for what things are. And just to show, now that I've written my code properly right here, I can do one other thing. I'm going to take this whole line of code right here, and I'm going to go to this, and I can quickly add in... Really? You want to start the line right there? Okay, sure. And I can go right here and go to... I want to go to PCH. Oh, good. PCH and change this to... Just to make this look better. And I'll go back. But you remember how we talked about graphics should be works of art? I truly believe that. Let's go 18 and 2. Didn't I like that? What did I do? I shouldn't break my code. PCH. Unexpected comma. Really? Okay. Data equals survey 10. One last try. Oh, wait. Okay, so that shouldn't be right there. There we go. Okay, good. I think it's working, just didn't like the graphic. Plot. I got it to work. Okay. I've done this before and I've stored it. PCH controls the point style. So you can change if you just do plot like 1 through 10 and you do PCH equals this, it changes, there we go. It changes what the point style is. So I can change that, and CEX changes the size of the points. So you can control the size of your points and all this stuff. So you can control the color of your points, the size of your points, all these fun things. So I was trying to make the outliers look a little more obvious with like an X on them, so that way we could see them. So I can control like, I could use the X right there, and I could put X's on them and all that fun stuff. And so there's the outliers in the data. One last thing I can do is I can go right here. This is the very last thing I'm going to do. Is I'm going to type AB line, and I'm going to go here and put M, and then we're going to go col equals purple. And really, oh, because I added the one last thing, and then we're hopping back to it. This, delete that off. Really, I broke it. Unexpected symbol. Oh, because I didn't put the colon. There we go. So now we got a purple line going through it. So now you can see the relationship between the data, and you can see this. But Dr. Petrie was so nice and created a thing that just visualizes it for you. So Dr. Petrie created that. This graphic right here is the same thing, and it's very similar, but I'm actually creating it by hand, and all I had to do was that. Okay, back. Let's go back. Brian had his fun. Okay. In fact, the correlation of speed in this is 0.91. Does describe the association. Choose. This is a, oh, it's got to be strong. Strong positive. Boom. Boom. We got it. Does that make sense on this one? Strong positive. Does everyone see why this is strong positive? Don't worry about those points. I don't think they're really outliers. They're not that far away. We have a way of measuring it though in statistics. Don't worry, I'm not gonna go along a side here. But the reason I showed this is because I can actually create numeric measures and figure out where the outlier points are. These 4 X's right here are these points right in here, that point, and that point. And probably this point down here, that point down there, all the way there, might be this one right here. Yeah, I think it is. Yeah, that's the one right there. So don't worry about this as an influence plot, but it helps us diagnose the regression, see what's going on with it. It's a diagnostic tool for regression. Pretty easy to run, just influence plot. What do we got right here? This one right here has a little bit of heteroscedasticity. Ooh, these two are really good. Graphics 2 and 3 are excellent. This one a lot of people miss. Because graphic 1 is like weak positive. Okay, so I'll tell you guys this. I might make a mistake here. I've made mistakes on this one before. Just because of the way they word it, I am able to make errors on this. Which of the scatter plots to the right show no association? So, which of them show no association? I would say what? None of them. I'd agree. I think none of them. Which of the scatter plots show a negative association? Only one of them. Only graphic number 3. Hopefully we get 100 on this one. This one's a tough one. I'm not joking. I make mistakes on this one. Which scatter plot shows a linear? Let's start at the very bottom. Does a line go through this? Does a line go through this? Like, would you say that has a linear form to it? Like a line goes through this? I'd say yes. Does a line go through this? Does a line go through this? This is the one that tricks people. Although it's weaker, don't look at the strength of it. Although it's weaker than the other ones, does a line still go through the data pretty well? It's still linear. So although it's weaker than the other ones, because it has more scatter across it, and it kind of has a change, it's weaker, but it's still linear. Linear only talks about if a line well describes it. Now someone's going to come to me and say, well, Brian, these points right here that are a blob, they can have a line go through them. I'll be like, well, the line doesn't describe it. That's a really great question, Neelan. If you have extremely weak, like if it looks like this, if it makes a 0, then that is then it's not really linear. It's like just not well described by a line because there's no linear relationship. If the linear relationship is 0, then it's like, well, then the line isn't appropriate. There's no association, no correlation. And so this one right here would be a no. There's other ones too that would be a no, like something like this is not well described by a line. That's not well described. Or a parabola. So these are all like not well described by a line relationships right here. Could you do a correlation for that though? You can always do correlation, but sometimes correlation is not appropriate. Radius of the circle is same anywhere, so no certain. Yeah, and so here you go. My graph doesn't make a 0. That's just points all over the place. Yeah. Does it look like? I'm guessing it looks something like. Let me not put it there because it's the wrong answer, or it's a one. Does it look like something like this? Does it look something like that right there, Morgan? You can barely see it. Does it look like that graphic right there, which is... Oh, no, get the mic out of the way. It does. Then if you were to draw around that, does that look more like a 0 or a 1 when you draw around it? Does that look more like a 0 or a 1? like a 0. So that means there's no correlation. Yeah. It won't always be perfect. That's what we kind of just like, if you draw around this, it's not super strong, but it's not super weak. So there's something going on there. So negative, it is 3. Which scatterplot shows a linear association? They all do. Hopefully I got that one right. Which scatterplot shows a weak or moderately strong? So I think they updated this a few semesters ago because you could call this weak. You could call it moderately strong. Scatterplot 1 is the way to go. Which scatterplots show, and I wish they just said, I wish they removed this. Just don't read it. Which scatterplots show a very strong association? Because they're not kind of strong, but very strong. Which ones show very strong? 2 and 3. Yep. Did we get 100? Woo! I was waiting. I was like, what do I say if I don't get 100? I was like, well, that's my Pearson for you. But the ones people get tricked on is that this one is linear. That's usually the biggest trick. Or if you get similar problems. Let's look at another version. This one's non-linear. That's non-linear right there. So the upside down U is linear. No. Nope. Non-linear. This will have a correlation close to 0. So this one right here. Good question, Josh, right there. Great question. This is non-linear. Non-linear. So, yeah, this would be strong. Yeah, this would be strong. Strength only measures vertical scatter. So this one here would be strong. Does anyone... This one is weak, negative, linear. And the questions change. That's... So, does anyone have another pattern that I haven't talked about yet? I think I've talked about all the possible patterns. Here's the one I think. I've seen this one. Obviously, I've seen these questions a lot. So that one right there that I'm hovering over now is 3 strong right here. Jack, I might have switched through. You might have to tell me about the pattern if I have to do it. These are the 3 you have. The top one is a moderate or weak positive linear correlation. It is linear. It is moderate / weak, or maybe moderate. It's not very strong. This one is very strong, negative. So remember, you're saying linear curve. That's a contradiction. Good question right there, Josh. So the upside down U is probably strong correlation. Let's look at the upside down U again. If I can get it appear. You appear. Come back upside down U. There it is. So that is a non-linear. That is non-linear. This is non-linear because it's curved. And so it's also strong. Why is it strong? How do we measure strength? How do we measure strength? How do we measure strength? By the vertical something. Because look, it's there. It's how tight it is around the form. Vertical scatter, you're right. So this one is very strong. Both of these, this is the strongest out of the 3. Even though the bottom one is linear, it's linear weak. It's negative linear weak. This is non-existent. And this one right here is whatchamacallit? It's a candy bar. Is non-linear, strong. Just remember, strong does not mean linear. Strong is how tight it is around the form. So very important stuff right there. Good stuff. Great job, Jack. Last few questions, right? Oh, well, that's more version of that. So, hey, we did that one. We don't want to show a complete problem. If we assume that the conditions for correlation are met, which of the following are true? Briefly explain. A correlation of negative, the one that looks like an exponential curve, and no, okay, yeah. I'll show that one. Good question. Where is it? There we go. This one is non-linear. It looks to be moderate / moderate strong. Tell me if they say that this... let's find out. Let's say 1. Let's say 1 and 2. Oh, we can't... Sure. We got to do the whole thing. Very strong, we'll say 3. Whatever you answer, you have to switch them up. Which scatterplots show a linear 2 and 3? Which scatterplots show a negative? None of them. Which scatterplots show no association? None of them. Whoo! Getting scared there. Getting scared. So they are calling this one moderate strong. They are calling that one moderate strong. So it's not linear, but it's give it a shot. Give it a shot. Give it another try. You guys got this. We can get some hundreds. You guys got it. So it's tricky. This one is tricky. It's caught me off guard, but they're calling this one here moderate strong, and it's not linear, though. So it's not linear. You can definitely tell there's a good curved nature to it. Where this one right here is linear, but it's weaker. And so they're classifying that one under the weak. So this one right here is the weak. And then this one is this one they're saying is a moderately strong. Is the downward parabola negative? Nope. It's non. It'll be non. It'll have no direction to it. Good question right there. The downward parabola, I think we have it on our drawing right here. There it is right there anyways. But even if it's a downward or upward, think about the line that would go through it. So if you were to put a line through this, it would be a flat line. So awesome. Good stuff. If it's the only thing that you've missed, I'll fix it for you. If it's the only thing you missed, I'll fix it for you. Did you get 100 on everything else? Say, Brian, you said did you get 100 on everything else? Was the only thing? If it's the only thing you missed. Because I do think that's... Okay, you got it, Nayland. You got it. I was saying that question's unfair. Like, you said that question was not fair. I'm like, okay, I said it. I appreciate you guys staying and doing all this hard work right here. Okay. A correlation of negative 0.98 is a strong negative association. Yeah, this is totally true. That is totally true. It's strong negative. Doesn't mean anything causes anything. It's strong negative. It's what negative 0.98 means. Multiplying every value of x by 2 will double the correlation. I think... You know, we can test this. It shouldn't do anything to it. Would it double the... It's not going to double the correlation. Just, obviously, it's not going to double it. I'll tell you why. Because imagine if the correlation was 1. If you multiply it by 2, the correlation can't become 2. So the answer is obviously no. So the statement's definitely false. It should have no change on it. I can go through theoretically. I can do an example of this. You could go here. And it's easiest to do it inside of R. That's why I love R. To quickly make some numbers. So watch this. If you want normal numbers, you can type random normal. And you can get 100 random normal numbers. So these are all z-scores. So we're going to save an x here as 100 random normal numbers. And then we're going to save a y here as 100 random normal numbers. So now we've put an x and a y inside of the brain of R as 100 random normal numbers and 100 random normal numbers. Now we go here to correlation. And the correlation of x and y can be found just with this right here. It says there's no y because I did a lowercase y, so we fixed that, and there we go. So the correlation right here is negative 0.158. And this is actually a correlation by random chance because I created random data. But what we can do here is we can double the x, and you notice nothing happened. There you go. That is, we showed proof by example. There, you could say, well, what if there's an example of this? But we just did 2 times x, and it didn't change it. You can do the other examples where you add 10 to x. Correlation doesn't change. So we can see that it doesn't matter if you add a constant or minus or multiply or divide. We could try all of those. And doing these to these variables shows that it doesn't change the correlation. So just kind of a good example right there where we create 2 random like x and y variables. It doesn't matter because it could have been any x and y, and then we run the mathematics, and the mathematics doesn't change no matter if we add, subtract, multiply, divide on the x or the y. So I will say this, though. Should I say the advanced thing, yes or no? Should I say the advanced thing, yes or no? And I'll tell you why this happens. I've lost everybody. We only have one more question. Yes, let's do it. If you were to take the log... If you were to take the log of x, it will change. What? Oh, because that. Is there zeros? Let's try to... Yeah, we can't change it. Let's add 10 to it. Okay. So you notice this changed it. There was apparently a 0 or something close enough. Oh, negative numbers. You can't log negative numbers. So 0 will get you negative infinity when you log it. Yeah, I think that one's next. We got that, Kelly. So the reason that it changed the correlation is because you're actually what we call transforming x. You're not shifting it. We call it a shift when you move it over, but you're transforming it and turning it into like a new set of variable. Yeah, I'll fix it for you, Jared. You got it. Email me, I'll fix it. So the plus 10 is not changing it here. The plus 10 is not the issue. It's that we are doing a log of it. Logging the variable actually changes the structure of it. And like when you think about how log changes things, this is the last thing I'm going to say on this. When you think about if you do log 10 of 10, it's what power do you raise 10 to get 10? The answer is 1. When you do log 10 of 100, it's what power do you raise 10 to get 100? And the answer is 2. And then you have to put in 1,000 because it's what power do you raise 10 to get 1,000? The answer is 3. You raise 10 to 3 to get 1,000. That's how you solve logs. But if you notice, it doesn't hit it equally. So if you had a data set, like we go here, that our data is the values of the vectors of 1, 10, 100, and 1,000, when you transform this via a log 10, you take your data and transform your data, you get the values of 0, 1, 2, and 3. So if you notice, it's not the same structural change. It's not a constant thing. Will standardizing the values make the correlation 0? Nope. Great question right there. Zulon and Morgan, great questions. So that's the fun advanced stuff right there. The units of correlation are the same as the units of Y? Nope. Correlation has no units. Did we get everything right? We got everything right. Correlation has no units. It's unitless. It's in z-scores. Z-scores are unitless. Oh, wait, did we do the Adirondacks one? Is that a chapter 7 one? I need to find that one, Kelly. I must have missed it. Exactly. And here, we got this one right here. We got it. If we assume that the conditions for correlation are met, which of the following is true? Briefly explain. A correlation of 0.02 indicates a... No. 0.02 is extremely weak. So this statement is false. A correlation of 0.02 would mean there's little to no linear association. 0.02 is very weak. It's close to 0. Choose the correct answer below. Standardizing the values will make the correlation 0. No. Standardizing the values is what happens when we do correlation, because correlation uses z-scores. So correlation is going to standardize them anyways. It won't change the value of correlation if you standardize them to begin with. The equation does it for you. So standardizing the values, it doesn't care because correlation is unitless. It doesn't care about the units of the problem. So this statement is false. Standardizing the values, nope, won't switch sign. Changing the units of both of the variables in this case will not affect. Yeah, that's right. Adding an outlier can dramatically change correlation. What should we say right here? Who's got it in the chat? I need to know the answer to this. Adding an outlier can dramatically change the value of correlation. True. You got it. That is a true statement right there. You got it. 100%. We only got tricked on one of them. Because outliers can do what? What is possible with outliers? Was it Kevin? You guys got to remind me who actually said it first. Outliers can do what? You're right. At that 1,000 points, Jared. Great work. Anything. Outliers can do anything. Where's the Adirondacks question? Is that in... I'll do it from chapter 7 if we want. Where's the Adirondacks question? Where's that Adirondacks question? Oh, wait, here it is. It's not linear. Woohoo! How are we doing? Is everyone doing well today? Might have some fun here. We might end class here in just a moment. Who got hundreds on the quizzes? I didn't mean to pump my knuckles. I just kind of... Sorry about that. Very sorry about that. It was right next to the microphone. Me, you got it. Nice job. So we did all the problems. Correlation is not that hard of a chapter. I think we did a great covering of it. Do you guys feel like you understand correlation pretty well? Like, regression kind of builds off of correlation. So, really think, great job here. So, are there any other last questions? I've got something fun here at the end. I'm going to go to my office and we'll do something fun here. So, I'm going to go to my office. I won't go to my office yet. But does anyone have any other last questions? You got it? Okay. So I'm going to go to my office, hang out here for just a moment. I'll be back. So I'm going to go to my office. Just wait here just a moment.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!